We are honored to welcome you to the joint conference, the third International Conference on Energy Storage Technology and Application ICESTA 2024 and the International Conference on Chemical Engineering, Environment and Applied Science ICCEEAS 2024 organized by the Chemical Engineering Department of Universitas Sebelas Maret and the Center of Excellence for Electrical Energy Storage Technology of Universitas Sebelas Maret. Before we start, I would like to introduce ourselves first. My name is Naila Rasya.
And my name is Aditya.
As the Master of Ceremony ICESTA ICCEEAS 2024.
The Honorable Professor Dr. Wahyudi Sutopo as the Dean of Engineering Faculty Universitas Sebelas Maret. The Honorable Dr. Joko Waluyo as the MT as the Head of Thailand, Mr. Rahayu Ginanjar Siwi STMSc from PT Pupuk Kujang Indonesia, and Dr. Sunu Herwi Pranolo STMSc from Universitas Sebelas Maret Indonesia. Ladies and gentlemen, please kindly give applause for our keynote speakers.
Before we begin, I would like to provide you with some important safety information to ensure a safe and comfortable experience for everyone during this conference. We are gathered here in the Indrapastra Ballroom located on the second floor of UNS Inn. This room has a capacity of 200 people. In the event of an emergency, please locate the nearest exit. You will find emergency exit signs marked around the ballroom. There are exits to the back of your seat that lead to emergency stairwells, providing safe access to the ground floor. During the evacuation, please remain calm and proceed to the nearest emergency exit. Do not use the elevators and use the stairwells located at each exit. Follow any instructions given by our event staff or emergency personnel. Once outside, proceed to the assembly point located in the parking lot of UNS Inn. In the event of an earthquake, please stay calm. Drop your hands and knees to prevent being knocked down. Take cover under a sturdy piece of furniture such as a table or desk to protect yourself from falling objects. If none is available, crouch down near an interior wall and cover your head and neck with your arms. Hold on until the shaking stops. Remain in place and do not attempt to exit the building during the shaking. After the shaking stops, check for hazard before carefully proceeding to the nearest exit. Avoid using the elevators and use the emergency stairwells instead. Move calmly to the assembly point and wait for further instructions from emergency personnel. In case of a medical emergency, our first aid station is located near the ballroom entrance. If you or anyone around you require assistance, please notify a member of our staff immediately. The ballroom is equipped with smoke detectors and fire alarms. In the event of a fire, the alarms will sound and you will be directed to evacuate immediately. Do not use the elevators during a fire alarm. We encourage you to keep all personal belongings secure. If you notice any unattended items, please notify a staff member. Also, please note that there will be no safety training scheduled for today. Thank you for your attention, and we appreciate your cooperation in ensuring the safety of all attendees. We hope you have a productive and enjoyable conference.
Ladies and gentlemen, to commence this prestigious event, we invite you to rise for the Indonesian national anthem, Indonesia Raya, which will be sung by all participants. Ladies and gentlemen are invited to stand.
we now invited our Dean of Engineering faculty to officially open the conference. For Professor Dr. Wahyudi Sutopo, the floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. Very good morning. Will not have spirit. Very good morning. Morning. The Honorable Keynote Speaker, Professor Surakarta from University of Malaya, Malaysia. Professor Dr. from Hong Kong University, Thailand, in online. Bapak Rahayu Ginanjar TV from Pupukujang, Indonesia. And then Dr. Sunu Pranolo from the University Surakarta. The Honorable Head of Center of Excellence for Electrical and Historic Technology, Professor Dr. Agus Purwanto. The Honorable Chairman of Center of Engineering Education, Faculty of Engineering, Dr. Lahan Solinasa. Vice Dean of Faculty Engineering, Head of the mutual collaboration of research, academy, industries, and governments. As reported by committees, there are 53 papers accepted by committee, under 24 papers from various papers that will deliver in either from the countries of Malaysia, Saudi Arabia, South Korea, Thailand, and of course from Indonesia. All accepted paper will be published in reputable journal, Evergreen, and also ASEAN Journal of Chemical Engineering and Open Engineering. Ladies and gentlemen, especially for participants and all of the students, global networking and understanding global culture are the important issues to consider by engineers in solving a real case problems. I hope that this event, ICESTA and also ICCEEAS, will trigger collaboration among the researchers who participate in this event. International engagement and cooperation are very important in solving the global problem that we are facing. Faculty of Engineering under Chemical Engineering Program Study and also the Center of Excellence for Electrical Energy Storage Technology UNS will be happy to assist all of participants to realize an international networking and also collaboration to establish building interdisciplinary collaboration to achieve sustainable development goals for the better future. The honorable of keynote speaker, invited speakers, participant, committee, and kolega, we would like to thanks for your all contribution to this event, and on behalf of Dean of Faculty of Engineering, let me invite all of you to say basmalah together to officially open this conference. Bismillahirrahmanirrahim. Finally, success is a part of progress. As a reward from moving forward, it is time for Indonesia. It is time for Universitas Sebelas Maret. It is time for Chemical Engineering Study Program to go global and be global. Thank you very much. Terima kasih and wassalamualaikum warahmatullahi wabarakatuh.
Thank you, and once again, please kindly give applause for the opening speech. Ladies and gentlemen, now we will present a Mojang Priangan dance performance. The Mojang Priangan dance originates from West Java and it's inspired by the Jaipong dance. This dance is a form of modern Sundanese dance that tells the story of the beauty and joy of women in the land of Sunda. This dance is performed by Kalista Putri Aziza, Alodia Simfoni Ramadan, Naila Putri Azhara, Ganesh Salma Sandrina, Anandia Fauzia Katarin, Vanessa Sagita Putri, who are chemical engineering students in Universitas Sebelas Maret, class of 2023. For all participants, please kindly give applause for the performance.
Angkat tangan Garelis maranis disinjang lalenjang estu suruh lempang mojang priangan digigirna diharap nasi
And once again, please kindly give applause for that beautiful performance. Thank you. Ladies and gentlemen, before we move to the next agenda, we would like to invite all of the attendees to take documentation together.
For all attendees, please kindly move forward to take a picture together.
Oke, semua partisipan diminta maju ke depan untuk pengambilan foto bersama.
Lagi Mas Fazan ini ra tiket kok. Harap.
We will now count in 3, 2, 1. Once again, 3, 2, 1. Thank you for all participants. Now you can get back to the seat again.
Dia bilang cek. Apa maksudnya? Hah?
Thank you for all attendees for documentation session. Ladies and gentlemen, with the opening ceremony complete, now we move to the first keynote session, which will be moderated by Mr. Anif Jamaluddin, PhD, and our speakers are Professor Dr. Ramesh T. Subramaniam and Professor Dr. Nonglak Mitong. We would like to invite our moderator and Professor Dr. Ramesh Subramaniam to come forward, and for Professor Dr. Nonglak Mitong will be join us by online via Zoom meeting that we displayed on the screen. Ladies and gentlemen, please kindly give applause for our moderator and speakers. Ladies and gentlemen, to make sure the session runs smoothly, I'd like to introduce you all to our dear moderator, Mr. Anif Jamaluddin, PhD. He obtained his doctorate degree from National Central University, Taiwan, and his master's degree from University of Indonesia. He was LG Electronics in Corporate Research and Development from 2003-2011, and currently he is Assistant Professor Physics Education, Faculty of Teacher Training, and Head of Quality Assurance Unit, Institute for Research and Community Service, Universitas Sebelas Maret. To Mr. Anif Jamaluddin, PhD, the floor is yours.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone, the Honorable for our Dean, Professor Wahyudi Sutopo, also for the Professor Agus Purwanto, and also for all of the keynote speaker today. Okay, this morning I want to introduce about the keynote speaker. We have two keynote speakers today. The first is Professor Ramesh T. Subramaniam. He is from University of Malaya, and also he is a dean in the Faculty of Applied Science, Applied Engineering. The faculty, the Institute of Advanced Science, and also he have many publication. Also have for the outstanding researcher and others. So it's so many activities. So we can give applause to Professor Ramesh T. Subramaniam. Okay, and another one, the second professor, the second invited speaker, we will invite Professor Dr. Nonglak Mitong. Is He's graduated from Material Science and Engineering from Massachusetts Institute of Technology, and now he is a full professor in Kokhon University in Thailand. And also we have many publication, and this research is especially for the lithium and sodium ion battery. So please give applause to Professor Noklah Mitong. In this time, we will invite Professor Ramesh to give a presentation around 30 minutes. So please, for the Professor Ramesh, time is yours. Okay.
Selamat pagi. I'm Ramesh T. Subramaniam. I'm actually from Malaysia. So I born in Malaysia. So I'm a third generation. So my grandparents actually migrated from India to Malaysia. So I studied everything in Malay. So I can speak quite a good Malay as well. So even science, mathematics semua kita belajar di bahasa Melayu juga. So I think quite similar to bahasa Indonesia. So it will be good. It make me much easier to do the collaboration in Indonesia as well. Okay, today I'm going to talk about the innovative electrolytes and electromaterials for enhanced energy devices. It's a 30 minutes given. I try to make sure I talk three important things. One, I want to introduce to you the University Malaya, the university that I belong to. Second, I'll talk about the topics which the conference belongs to, energy storage. And third things I'm going to talk and share with you is some of the opportunities which I do share with last time. And then a lot of good networking has been continued after that. So this will be like a three-part of the talk that I'm planning so that it can benefit all of us. Not just I come here and I give a keynote and go back like that, because it must be a continuous collaboration. Okay, first, University Malaya. I'm sure you all heard about that. So this is our new, what I call tagline, home of the bright, land of the brave. Okay, you can see that. Di sini bermulanya pintar, tanah tumpahnya berani. So this is our tagline, the new tagline from our new Vice Chancellor. And if you know the history of University Malaya, we started in 1905. So it's more than 100 years. And then it was developed as a Raffles College Singapore. And if you know the history, Malaysia and Singapore were together once. Then they become two different countries. So University of Singapore, which is the NUS, National University of Singapore, and University Malaya are actually together long ago. Even if you look at their logo also, you can see quite similar. And we also got our own hospitals, which is well established one. And here are the vision and the mission. So just now your dean mentioned about the Go Global. So you can see our vision also like a global university impacting the world, with a mission pushing the boundaries of knowledge and nurturing aspiring leaders. So the knowledge and scientific leaders are crucial for the development of any country. Okay, these are the flag bearer of Malaysia. Even though sometimes there will be always argument whether the QS ranking important or not, but this is always important because this is where the opportunities generally comes from. So if you look at the QS World University Ranking, University Malaya ranked number 60, and also in Asia we are in the number 11 in the QS World University Ranking. So this is based on the impact of the research towards the global. And next I want to mention to you about this UM profile, because there are many opportunities in University Malaya. So we got 14 faculties, 2 academies, 2 academic center, 4 research clusters. And you can see our undergraduates number of students is about 20,000 with 14,000 postgraduate. So our postgraduates is quite high because we are the research university. So the ratio of the undergraduate to postgraduate, normally close to be 1-to-1. And we got many international students, more than 8,000, and from many countries as well. And we got like one continuing education center as well. Okay, here you can see in total we got like 77 undergraduate programs. So either science or social science or engineering, and so many things are there. And we have a 150 master's degree program. So this master's degree program is like coursework. So we attract many foreign students to come and join for this kind of a master's degree program. And doctoral degree programs got 28, and then 2 double degree programs, and 3 dual master programs, and 6 collaborative PhD programs with renowned universities from overseas. And here are the research clusters under University Malaya. So like social advancement and happiness, health and well-being, innovative industry and sustainability, science and frontiers of the natural world. So any research can come under this category. And this is a faculty of science where I belong to. So here you can see the Kuala Lumpur, our University Malaya in the center heart of the capital city, Kuala Lumpur. It is a very beautiful campus and a very great campus. Few of your staff from here actually visited us. We got a very nice lake as well. So if you got the opportunity, you're always welcome to University Malaya. You can always contact me so we can arrange things for you to visit us. Okay, this is another thing what I want to share with you. They call Institute Pengajian Termaju, Institute for Advanced Studies. So I was just recently about 2 weeks ago appointed as a dean for this institute. So this institute cover all the multidisciplinary throughout the University Malaya. So a lot of opportunities and fundings are available there, like visiting professors, adjunct professors, and quite a number of master's program and PhD programs are all available. Please go to the website and look into it. So any opportunities matching with you, you can always write to me, then we can arrange how we can collaborate. Because we are actually planning some what I call like dual campus with China as well, Xiamen University. So it's a G2G what I call like approach. G2G means like a government to government. So even we can do this kind of things with Indonesia as well. So these are kind of good opportunities as well. Since now I am the dean, so I got the more authority to make the things done in a right way. Okay, next. That's the first part about the introduction. Second, I go to the topic, the energy storage devices. So now is a time people talking about the Nobel Prize winners. So we are waiting for the Nobel Prize winners for chemistry to be announced soon as well. Even for S3, they announced for the physics is more to the AI. So AI and machine learning is coming something new. So if you look at the energy storage, 2019 Nobel Prize in chemistry was given for the development of lithium ion batteries. Even though lithium ion batteries is already there for such a long time. If you look at your handphone batteries, so like I was doing my PhD early 2000. So I completed my PhD in 2004, 20 years back. So if you see means the handphone during that time was something very new. And people talk about the nickel cadmium batteries. So if you recall back those days, the battery is very big, very huge. Very huge. Sometimes you can hold the handphone like this and you throw to somebody. If you have angry means it really can hurt them also. Even if you put inside your what you call like pants, so you need to tight your pants with a belt because that heavy. So your pants can come down as well. So that heavy, because it's a nickel cadmium batteries. So later you see means it developed become as a nickel metal hydride, and all these metals are heavy metals. So that is where scientists come up with the idea to use like a lithium. Why they want to use lithium? Because if you look at the periodic table, the first element is a hydrogen, then helium, then come lithium. So the first metal which got the lightest element is the lithium. So that is where it comes to the lithium ion batteries. So the difference between lithium ion batteries and lithium polymer batteries is when they use lithium ion, it is in the liquid state. The electrolyte will be in the liquid. When we say there's a lithium polymer batteries, that means is what? They want to change the liquid to make it in the solid state so that the whole device will become as in the solid state. So that means like a leakage free and all these things we can make, and the whole thing be the solid state. So why I'm putting this slide here is 2019 Nobel Prize in Chemistry for the development of lithium ion batteries is already given. So we must think what is next. how to make these lithium ion batteries to the next level. So that's where comes the lithium ion polymer batteries and also the other novel materials that we can use to make these energy storage devices for the next level. And also this conference also we see means about energy storage. The Capital Group make a prediction for the next decade, which is up to 2030. They look, autonomous vehicles will hit the fast lane, green machines will rule the road, renewable energy will power the world. So that means the market for these things are hugely, very huge. Even recently, China come out with a new grant, which they're going to announce in November, most probably. That grant also focusing more to the energy storage. So this field really got the value. So if we do the right things at the right time, we can actually tap in quite a lot of money, and this will help us to do excellent research towards the betterment of the country. Okay, here, why we want like energy storage and why we want all these things, because we always want sustainable cities. So even yesterday night, I was talking to Dr. Anif and what I call is a colleague regarding the smart cities. And we also got a project with the EU regarding the smart cities. So the smart cities is what always we prefer it. So you can see the sustainable smart cities need to be cities with the parks, green spaces, solar powered buildings, rooftop gardens and so on. And we must have a good quality of life. And it must also what I call like a complement with the space for nature, eco-friendly public transport system, and the usage of the solar energy. So all these things are crucial. Okay, how are smart cities related to our work? So here are the three important components there: economic, social, and environment. So before we do the research, we must have some kind of idea how this is going to impact the societal impact. So our focus is on transport system, specifically on energy storage system for electric vehicles. So the three dimensions I mentioned to you, the economic, social and environment, our target is environmental and economic aspect of smart, sustainable cities to reduce air pollution and carbon dioxide emission and create job opportunities. Because nowadays we talk about the net zero carbon emissions. So if some of the countries, like if you see means like a Bhutan, they already having towards the negative zero emissions. But some of the Middle East countries, they may not be agree with this. But our target, we still need to go towards the net zero carbon emission. Okay, when we talk about the energy storage devices, these are some of the topics that we are doing, I wanted to share with you. Okay, here you see means supercapacitor. I'm sure you heard about like a supercapacitor, and you heard about the battery as well. So normally batteries, they will give you high energy densities but low power densities. Whereas supercapacitors is opposite. They give you like a high power density but low energy densities. If you want to use for electric vehicles, you need to have both these things together. So when you have a supercapacitors and batteries together, it consumes space and it also consumes cost. So is it possible or not to make all this together in one device? So that is where we come out with the idea to call as a supercapacitor. So from the name itself, you can see it's a combination of supercapacitor and battery. This one behave more like a asymmetrical device. So one side we use like a battery type electrode, and the other side we use a capacitive type electrode. So that is a main concept. Beside that, for us to get the optimum value or optimum performance of the energy storage devices, we need to take care of the electrolyte and also the electrode materials. So when we talk about the electrolyte materials, like I mentioned earlier, initially they use liquid electrolyte, which is using the lithium ion batteries. But liquid electrolyte got a huge problem like a leakage and so on. So then we come up with the idea of the solid polymer electrolyte. Solid polymer electrolytes can overcome the defects from the liquid electrolytes. But the problem will be the contact. Because when you sandwich all these materials in the solid state, so that can be a problem to get a good contact. So how to improve the electrolyte, which I'm going to explain in my next slides onwards. Even the electrode. The conventional electrode, normally they use the binder. The binder they commonly use is a PVDF, polyvinylidene fluoride. But what happened here is, since you are using polymer as a binder, they will behave as a insulating materials which can decrease the conductivity of the devices. So how can we do the binder-free electrode materials? So these are the concepts that I'm going to explain with you. Okay, here, the three drivers that promote the investment in energy storage: the increase in electricity bill, growing dependence on fossil fuel, and decarbonization. Okay, this is in terms of the Malaysian perspectives. Malaysian carbon dioxide emission in 2020 increased 69% compared to 2000. So if you look, that means one of the main industry that contributing for the high carbon dioxide emission is the transport industry. So how can we reduce these things? So how can we contribute to reduce the carbon dioxide emission by this transport industry? So one of the things we can use is the electric vehicles. And current electric vehicles are mostly powered by lithium-ion battery technology. But the problem here is this EV takes 4 hours to fully charge. But we want something fast. So the 4 hours is really, really long. So people prefer to go and just use the normal petrol. And like I mentioned earlier, the new type of the energy storing device, the supercapacitor, can solve this problem. And also, this energy storage device can be integrated with the energy harvesting devices as well. So if you look at the energy harvesting devices, one of the easiest to prepare is a dye-sensitized solar cell. But the problem with the dye-sensitized solar cell is it's easy to prepare, but the efficiency to get 10% is a bit difficult. So when you compare with the solar cell, which from the silicon, and also the perovskite solar cell, the efficiency always more than 20%. So even though this DSSC give you lower than them, how can make this DSSC as a useful? So this DSSC, even though they give efficiency lower than the silicon solar cell, by incorporating them with the energy storage devices, we can have a better usage of these DSSCs. Okay, I just want to share with some of the initiative from the Malaysian government. So we got like a national automotive policy. So why I think this research is quite important, got a lot of opportunities for the collaboration, because the list of technology development program under this national policy involve both, you can see both the lithium ion battery, which is the energy storage devices, and also about the next generation battery technology. The first point you can see they actually focusing on the electrode and electrolyte materials as well, the advanced one. So if you write a good proposal and got a good idea about this area, we got a good chance to get a good funding to run the project with the successful. Okay, the supercapacitor, how this device related to the policy, you can see it supports the electrification of vehicles in Malaysia. We can produce supercapacitor that would have a longer lifetime and longer drive distance. Like I said, the time and distance are very important. So we must have the capacity to do both these things quite well. And also to produce the normal electrode and electrolyte to fabricate supercapacitor. So I will share with you some of the electrode materials, that electrolyte that we are doing after this. Whenever we talk about the energy storage devices, the 3 items that we need to take into consideration is electrolyte, electrode, and device itself. Regarding the device, I already mentioned to you earlier itself. Regarding the power and the energy need to be compromised. Regarding the electrolyte, the liquid electrolytes are always harmful and prone to leaking. The other options are by using like a solid state electrolyte, or we are using like a synthetic polymer. Because these synthetic polymers are non-biodegradable and also flammable. Because when we use a lot of polymers, that's also risky. Next, for electrode, we can see that when you use a binder, they can increase the resistivity, and also another important thing is they will add unnecessary weight. This is called dead weight. So when you have the unnecessary weight for the electrode materials, this can also decrease the performance of the devices. So we need to overcome all these things as well. Okay, next I'm going to talk to you about the evolution of polymer electrolytes. So how to make the polymer electrolytes a successful candidate to replace the liquid electrolytes? Because people still prefer liquid electrolytes because they show the excellent properties. The first generation polymer electrolytes, if you see, means salt-based polymer electrolytes. So these are first generations, the first starting point. So the lithium ion which they use in the liquid electrolyte, they incorporate this lithium into the polymer. But remember, lithium ions are positively charged. So the polymer that you are using as a host material for these purposes, they must have the electronegative element. For example, polyethylene oxide. Polyethylene oxide can be used as a polymer electrolyte because they got the oxygen element there. But polyethylene, we can't use it because they only got the carbon and hydrogen. So we must find the right polymer. Then for example, polymethyl methacrylate, another interesting polymer that we can use because they got the as the functional group. And also polyacrylonitrile, you can use that as well because they got the nitrile functional group, where nitrogen is one of the most electronegative element as well. So all these can work. So that is the first generation. But what happened here is, when you use only salt, the conductivity can be increased compared to the insulating polymers, but not good enough or not sufficient enough to make the conductivity high. Because normally we need about 10 to the power of -3 Siemens per centimeter to have the good conduction properties. So that's where came the second generation polymer electrolytes, where they use plasticizers. When you talk about plasticizers, they are like a clay, you know. So like you are adding water to the clay to soften. That is what we call as a plasticizers. So by adding appropriate plasticizers like ethylene carbonate, propylene carbonate, we can increase the conductivity. But the problem with these plasticizers is their mechanical properties deteriorate. So then difficult for us to handle. Even though they got very good conductivity, but difficult to handle. So that's where come the third generations, where we are using the nanoparticles. When we use a nanoparticle, the conductivity can be enhanced. The mechanical properties also can be enhanced. In addition, we also can improve the aging effect. When I said aging effect means they can retain the high conductivity with a prolonged time for many years. But in progressive years, they also use radiation method, iron liquid and so on to improve the performance of the devices. Another important component that you can use to make the conductivity high for electrolyte is ionic liquid. So these ionic liquids are room temperature ionic liquids. So even at room temperature, they are in the liquid state. So what is the advantage of this ionic liquid is, normally polymer won't dissolve in aqueous solvent. So the best will be using like a organic solvent, like acetone, what they call like tetrahydrofuran, kind of an organic solvent. So when you use this organic solvent, they are environmentally not friendly. So the best will be ionic liquid. So this ionic liquid not only dissolve the polymers, but at the same time they also can be like a charge carriers. So mobile carriers to make the conduction even better. Another new type of work that we are doing is to change the polymer electrolyte to become as a hydrogel electrolytes. So hydrogel electrolyte can be made as a physical hydrogel or chemical hydrogel. So for the physical hydrogel, you can see the physical interaction and ionic cross-linking will be made. Whereas chemical hydrogels are made by the new covalent bonds formation by using appropriate cross-linking agents. By doing this method, the polymer electrolyte, which is rigid and hard, can become more like a gel. So we can actually get a good contact between the electrode materials. So here are some of the examples. Any polymers, like for example like a polyvinyl alcohol, polyacrylic acid, polyacrylamide or any kind of a polymers, we actually can use them as a polymer, which they become as a polymer electrolyte, but with the appropriate technique we can bring them towards as a hydrogel, then we can use them as a hydrogel polymer electrolytes. The methods are stated here. Okay, we can find in any of the literature. We can also use the same thing for the biodegradable materials like a chitosan, cellulose, guar, carrageenan, pectin, all these things also can be done. Few of these polymers we have converted them as a hydrogel electrolytes, and successfully we conducted some work on that. So why hydrogel as electrolyte? See, they are very flexible. They are also got the self-healable properties, hydrophilic, thermally stable, compressible, and stretchable. You can stretch them is a more than 200% as well. So all these are the beauty. So here, some of the pictures I put that. So we can do like a bending, we can twist, we can even do the knotting as well. So the stretching you can see like a more than 200%. So that means this kind of electrolyte can be used in the flexible energy storage devices as well. This is what I mentioned to you, like a self-healing properties. Just say some kind of a defect happened inside the device. They got their own properties where they got like a cross-linking agent. Even after, for example, you cut them to make them as a two pieces. So you can actually connect them together, then you can see, you can get a very good properties as well. Okay, here are some of the results. The synthetic polyacrylamide hydrogel. So for this work, we use appropriate cross-linking agent, and then you also can see some kind of what I call like acrylamide, ammonium persulfate, and so on. So all these can be used to make them as a hydrogel electrolyte. So here is what I call like their SCM images. It shows that a good morphology can be created, and also EDX confirms the presence of all the relevant materials. So here are the results. The results shows that what we call as the hydrogel polymer electrolytes can show improved conductivity, capacitance, and also the values from CV and also the GCD. Okay, next I will touch a little bit about the electrode materials. When we talk about electrode materials, the porosity, size, composite, doping, all these are crucial. So here is a synthesis of the ternary nanocomposite. So you can see that. So we can put like a nickel phosphate, you can make them as a binary nanocomposite, we can also make them as a ternary nanocomposite. So there is no binder here. So this can be coated directly to the nickel foam. The other things we also work is on the magazine. So magazine is a new type of materials, is a very good for electrode materials, which can come from the max phase. So the max phase is from the table you can see, either is a carbide materials or nitride materials. So one of the main concept for us is we should innovate here, we should make here and deploy everywhere. So I think this should be our motto for Malaysia and also Indonesia as well. So for us to become as one of the top ASEAN to be the one of the top contributor for this research. So next I will go for the all-in configurations. So this method is a bit different, where actually we make the electrolyte film and we polymerize, we coat the electrode on top of the material itself. So that means the electrode and electrode will be together in one piece. At the end you will get a product like this. So in this product actually electrolyte in the center and it is already sandwiched by the electrode materials. So we already deposited. So this is what we call as a all-in-one configurations. The next will be what I told you earlier also. How can we connect the energy harvesting and energy storage devices? By having the complement electrode materials, actually we can make them as a hybrid or integrated devices so that we can get the both energy storage and energy harvesting together in one device. Okay, this is a way forward. So electric and hybrid vehicles are better than petrol diesel vehicles. The manufacturing cost of the supercapacitor can be lowered, and supercapacitor with these novel materials can be used in future advancement as well. Okay, next I just want to share with you, because there is a 1 minute plus there. So just want to share with you some of the opportunities that are available in Malaysia as well as in Indonesia as well. So one of the things is a Fulbright scholarship. Indonesia is one of the main players as well. So please go to the Indonesian, what I call like a Fulbright website. If you got any opportunities, you look into it. So I'm actually a Fulbright scholar, and also like a Fulbright, the US Embassy appointed me as a panel for the selections. So if you need any advice, you can always contact me regarding this Fulbright fellowship. And then GOIA, this for the academic staff who are, and also like postgraduate students or students in future, those who are below 40 years old, the Global Young Academy, the headquarters in Germany. I'm the actually like an alumni of this GOIA. and also in the selection committee. So there are a lot of grants and fundings and opportunities there. So please apply for this as well. So if you need any advice, you can always contact me as well. And then TWAS, the World Academy of Sciences, like Malaysia and Indonesia, we are under Beijing, the Chinese Academy of Sciences. So I'm actually a fellow at this TWAS, and they also got a lot of fundings and a lot of what I call networking and collaborative efforts. So please look into the opportunities. If got, always you can contact me. Next one is the ASEAN India. This is another grant. So this year I put a grant together with the Universitas Sebelas Maret. Hopefully we can get at least one. So there are more opportunities on these things. So Indonesia is one of the ASEAN partners. So we can work, because for this project they need 2 ASEAN partners. So Malaysia, Indonesia, we can always work together to get these opportunities. And then another one is Erasmus projects. This one is like a 1 million euro projects, quite a lot. So actually we are working with UNS also to put at least 2 or 3 proposals for the coming call, which is next February. So we're working on that. Hopefully we will be successful as well. So whatever the outcome is a secondary. We should be a player. We should apply first. So now we are doing the brainstorming and working on that. So hopefully this will connect more UM and UNS in future as well. So they got like an international research and capacity building. Okay, last but not least, just excellent PhD scholarship. So those who got a good results, you can also apply in and you can do a PhD in and of course we can have a supervisor from and also UNS. So that means it can be benefit both sides, the academic from and also academic from UNS or any other universities from Indonesia as well. So that is a very good opportunities. Please look into that as well. Okay, if you want to go fast, go alone. If you want to go far, go together. So one of the reasons I come here is, that's the main reasons, we must go far together, because there are a lot of opportunities. We shouldn't take us as a competitor. We need to complement each other, because this field is really big and vast. So hopefully we can grow together. And then the last acknowledgement to my family, always support me, all my teachers, students, collaborators, University Malaya, friends, and not forgetting taxpayers who really pay our salary and the grant. And a big thanks to Dr. Anif, because he's the one who connected me to UNS. A big thank you to Anif again. And then with that, thank you.
Okay. Thank you very much for Professor Rames. Please applause to him. And also before we have some discussion, but we want to invite one more keynote speaker. Her name is Professor Nonglah Mitong. He will join with us in a Zoom meeting. Hello, Professor Nonglah.
Good morning, Dr.
Good
Ani.
morning. Okay. Good morning, Professor Nonglah. Okay. How are you? Fine?
Yes.
Okay.
But I heard myself that it's echoing.
It's echo. So maybe
Yeah.
can you... Hello? Hello, Prof. Okay.
Yes.
It's okay? No, for the sound is better than before?
Not really.
Okay.
I sing to myself.
Back sound.
Yeah, I checked Dr. Cornell this morning, but it was not echoing, but right now it's very echoing.
But in here we hear you very clearly. Maybe some of
Okay.
us. Okay. Okay. You have around 30 minutes to present about your work, especially you are advanced in lithium and sodium ion battery. So please, time is yours to Professor Nonglah to give a presentation to us. Okay, time is yours, Professor.
Great. Can you hear the slides? Can you see the slides? And Yes, I assume everyone see the slides. Okay, all right. So let me start then. So good morning, everyone. And first, I would like to thank the organizer for inviting me to join. I really, really want to join in person. I had been to Indonesia and UNS for several times, but for this time, I have to be from online. So next time, I hope I can join in person. So the topic of my talks today will be extending on what Professor Ramesh was talking about, the importance of new materials and innovation. And I will focus more on trying to bridge the innovation to production in order to get them into practical application. And hopefully end with the potential collaboration that we can continue. I've been working with many professors, especially Professor Agus Purwanto at UNS for several years, and hopefully we can continue and extending our collaboration between KKU and UNS and probably UM in the near future. The place that I come from is Khon Kaen University. So this is where exactly it's located. It's in the northeast of Thailand. The university itself is one of the largest public regional universities. We have over 40,000 students and about 10,000 faculties and supporting members. I think good thing of speaking after a very knowledgeable professor like Professor Ramesh is that I don't have to introduce a lot of things. I'll go directly to the topic of my talk today with trying to basically reaching the same goal as other people that are working in new energies and working in clean energy area. Is that we are all trying to achieve the global net zero, right? Like this part, I show several countries. Thailand itself, we do have several plans that meeting and raising in order to get into that global net zero status, especially relating to energy storage or battery technology is, for example, we need batteries for EV. So Thailand has a very big and one of the most successful policy that drive the use of electric vehicles in Southeast Asia. In Thailand, I think we are number one in terms of sales of EVs, but of course, just adopting and using as a market, it's definitely not the goal of researchers, right? So we want to be involved and hopefully getting into the supply chain somehow, not just being a good users, right? In addition to EVs, also the uses of clean energy, especially from renewable energies, we definitely need the good batteries or good energy storage. Right? So I will talk and discuss a little bit later on. So basically, we all know that all those clean energy, especially renewable energies, we need some sort of storage, right? But in order to get that into a large deployments, we need a lower cost energy storage as well. Professor Ramesh was talking about a new concept of supercapacitor plus batteries and many other technologies. So today I will talk on hopefully a lower cost approach based on new materials, cheaper raw materials, as well as new type of battery called sodium-ion batteries, right? So we all know that the batteries is not just for car. It's not just for energy storage for like big application for renewable, but it all applicable and highly related to all the people, especially everyone here's life, right? Its size of the battery can range from very tiny ones in medical devices to bigger ones that we are very keen on, like in portable electronic device, and also in other unknown applications that I didn't talk about here, like in space application, for example. Data centers is one of the things that's coming into our life, right? Like data center, I think maybe especially Professor Ramesh know that Oracle actually is setting up a very big data center in Malaysia. So those also require renewable energies and batteries, but it has to be very safe and very, very low cost, right? So those are the application of batteries that signifies the importance of research in getting better and higher performance batteries, right? But for us as researchers, what are those batteries means to us, right? So when we talk about the performance parameters or index of performance indicators, for battery we think of better or higher energy densities. So that means it's for example, for your portable electronic devices, it's take you many days before you have to come back and recharge. For EV, you can drive longer before coming back and stop by or recharging at a charging station. So higher energy density coming directly to the new materials, especially like silicon or high voltage cathodes or even new concept of anode-free system, right? The second parameters are relating to safety of the batteries. So this is directly related to what Professor Ramesh was talking about, is about the polymer electrolyte, about the changings of new flammable materials into less flammable material or adding something into it to improve this safety index, right? The third parameters is relating to power. So this one, for car, it means acceleration. For renewable energies, it means absorbing the excess energy that's generating from renewable sources. For example, when it has very high wind or very intense of solar. So these will allow absorbing those excess energy and to be used in different times, right? This also related to materials that use in the battery component. Cycle life is a big thing because cycle life is actually relating to the last thing that on the parameter list, which is the cost. So many of us know that when we try to apply new energy storage system into any energy application, the question is always the cost. Lithium-ion batteries are originally used to replace lead acid, and lead acid is one of the very low-cost choice of storing energy. But if we think of the overall cost of ownership, meaning if we multiply the initial cost with the life of the batteries, we might have better option. For example, lithium-ion batteries can be more affordable in many applications compared to lead acid if cycle life is critical. For example, long duration energy storage, right? Or if we combine cycle life and cost, it's maybe other options that are better than lithium-ion battery. For example, sodium-ion battery might be a better choice, right? So these are the 5 key parameters that we normally, when we do research, we have to always think about it. And those all 5 parameters are enabled by discovering or understanding more on the material, especially new materials that are being studied worldwide. For materials that we are focusing at KKU, so for the lithium system, we all know that there are many components, right? There are a cathode, there are anode, a separator or electrolytes, or and in the cathode anode itself, there are many varieties, and also in addition to the material level, is also in the cells configuration level. There are many cell configuration level at the moment. There are cylindrical cells, pouch cells, prismatic cells, and all that type, right? So researching into those are very critical. In addition to lithium ion, we also know that there's a vast varieties of materials and system that beyond lithium ion batteries that are a good opportunities for researchers to work on, right? So basically just like, again, as I mentioned, Professor Ramesh many times, because he has shown that the research landscape in batteries are very vast and has a lot of opportunity for collaboration, even for scale up to become commercialization, okay? Here I'll talk a little deeply on what we are working on at KKU, and hopefully some of these topics can be of interest in the audience, and it can initiate future collaborations in the near future. So over here, the technology that we focus mainly at the moment from material level up to application levels is lithium ion battery. We do produce silicon from two sources, from rare earths and from solar cell waste that can be turned into anode materials. And these anode materials can come into many forms. In terms of like nanoparticles, in terms of composite materials, or even new type of materials like silicines. It's one of the silicon sheets. So these are being studied from the lab and then make up into a larger scale and make them into a cell application and into product at the moment. I will talk a little more on the facilities that we can do from those cell material, from that materials up to cells and into product in just a few minutes from now. So for example, when we do research on material level, right? So we study everything from electrochemistry, material structure, into how we make them into practical application. For example, if we apply in application requiring like quite high power, like in electric vehicles, motorcycle, we probably have to study to make sure that those new materials can last very long. Practical number of cycle life for a EV or a small EV right now is at least a few thousand cycles. So as a researcher, we have to prove that at least materials can sustain over maybe 1,000 or 2,000 cycles, right? So these are just some of the example that, okay, these materials, it can make out of silicon solar cell waste and then cycle over 100,000 cycle. These are the materials that I mentioned about. It's nanosilicon recovered from solar cell waste. The blue sheets on top of the solar cells that you see installed like many places like in Southeast Asia, those few thin layers is the silicons, pure silicon materials. If we recover from end-of-life solar cells, we can upcycling them into more useful materials instead of like dumping into landfill, right? So these are example of materials that we make. We make them into what we call silicene or multi-layer silicene. It can be used in battery application. These are just a few nanometer thick sheet of silicon material we call multi-layer silicines, the process itself can be scaled up quite easily, so it can be large scale, and hopefully this can expand into a pilot scale production and eventually being part of the circular economy to produce batteries in the near future. We also do some fundamental research, not just like making materials. We do collaborate and has the computational power at our universities, combining with some advanced characterization tools like synchrotron facilities. Many of us here that we have been working together have used the synchrotron facilities before in Thailand. So these are very, very powerful tools when we combine with experimental advanced characterization and computationals. We can understand materials and can design even better or more suitable material for future generation of batteries and battery materials. Also, we also work in other components. The reason that we work on binders is that binders can be a dead weight in many battery applications, but binder itself can also be used as a changing tools for making electrode in a new way. For example, in dry coating techniques, binder is very, very important. The majorities of how we make batteries at the moment is using liquid type binder. So that liquid type binder required coater and drying process afterward. But if we understand how binders work and can use new binders that combine with material without adding the liquid into the coating process, it will be a revolution. Right now, there are companies that are trying to make drying electrode to be commercialized, for example, Tesla. But there's still many problems because the lacking of understanding of the interaction of components in making the batteries, especially coming from the binders component, right? So that's why we also working on binders. For new type of batteries like sodium ion or aluminum ion batteries, we also work on new materials. For example, for this sodium ion batteries, we produce laser-induced graphene or graphene oxide to be applied as electrode materials. So this technique can be very efficient, can be scaled up, but at the moment it's not yet easily because the laser type, the laser size itself is still small. But it will, if we think of green chemistry or the process that use less chemical, these type of physical method will be solution in the future. If we don't have limitation of the system itself, it can be very green route of producing new battery materials. So these are also a new type of materials that we are working on. It's a cathode materials that are generating from more widely available materials. It calls NMVP, sodium, manganese, vanadium, phosphate. Vanadium is still quite rare, but manganese is more abundant. But it has the limitation of cycling stabilities and weight capabilities. So that's why we have to investigate this material using many different techniques. Doping is one of them, of course, and also one of the simplest one is just combining those material with widely available type of carbon additive. For example, activated carbon from coconut shell waste, we can use as one of the good way to improve the kinetics of these materials to improve rate capability. Other type of carbon can also be used, of course, and in our area like in Southeast Asia, we have more variety of biomasses that can turn into carbon materials and be part of the supply chain of making better material for batteries, right? We also are doing a new concept of recycling. So basically, we turning waste from lithium-ion batteries expenses into new sodium-ion cathode materials. So this is a completely new concept of removing waste from lithium system, extracting lithium out, and inserting sodium in, turning X lithium ion into new sodium ions. So at the moment, it's still in the lab and investigating more on how the phase transformation change when we do this, which will, of course, impact cycling stability, rate capability, for example, using the synchrotrons facilities that we have. For aluminum ion battery system, we have been working for this for a really long time because we know the benefit of aluminum is instead of lithium and sodium, we just have one ion exchange per mole, just 1 plus, right? But for aluminum, we have at least, we know that 3 electron per mole is possible. But the challenge of aluminum system is that it's highly corrosive. The material itself needs a lot of research and investigation. On the anode itself, aluminum itself, when it alloy, the corrosion property change, so it needs to be understood in order to use in the long term. For the cathode, carbon materials are one of the well-known one, but we probably have to open up for new potential other kinds of chemistry, just like what we see in lithium system or sodium system. Maybe compound type materials are the solution, yet we don't know. So these are open for potential collaboration in the future. From materials innovation, in order to make them into practical application, I think many of us know that in one battery is those many components, but how we can prove that those things that we add into hopefully new commercial product is really usable or feasible. Usually this is the way that we do, right? I think it's quite similar thing as what Professor Agus Purwanto has been trying to develop the ecosystem in Indonesia, is that after we make from the lab, with usually materials in level of gram, we have to scale them up into a batch size of kilogram and eventually trying to reach them into real production of like a ton of production. Making from small cells, like in coin cells, into a more practical oriented, like cylindrical type or pouch type, require materials as well as cells scale up, right? Even for real application, for example, if you want to make them into electric motorbike, these also require many different angles: material development, cell development, pack development, along with compliances to standards, right? So in order to make this, there's a lot of investment involved. So if we can do our collaboration and implement each other in some way, that will reduce the gap of, making materials in the lab and reaching the customer into real practical products, right? Especially for our regions that we don't have a lot of research capability to scale them, reaching the certification level and then making them into product. We have to work together even more, right? So here is the facility. So this facility is welcome to collaborate, right? We do have compliance into many international standards, right? Like for transportation, for cell level, for EV, for portable electronics, as well as for some application like some motorbike. So this require very specific standards, and this we open for a collaboration. These are just example of the product that we have been developed or co-developed with our partners or researchers around Southeast Asia. And probably going to be extended further into India or into China if we have partners, right? So this product is start out from research. Always start out from research, like new material component. We study like how we formulate, for example, this project, we have new carbon nanotube from clients and want to be tested into a motorcycle type, right? So we work together from formulation, make them into small coin cells, make them into cylindrical cells, and finally test them in real product, like in motorcycle, as I mentioned. So these are example of the facilities. We have production facilities, we have testing facilities, both performance and safety standard. So these are open for collaboration. So so basically, I think in this 30 minutes talk, I show you that there are many area for potential collaboration to strengthen the ecosystem of battery R&D in Southeast Asia, in ASEAN, and hopefully, if possible, we can bring materials innovation into the market using this facility that we think of standard alliance from cell level to pack level, so that you can bring your innovation into market easier. So thank you for your attention. So if you have any question, I'm very happy to answer. Terima kasih banyak. Thank you.
Thank you. Okay, please give applause to Professor Nongla. Okay, thank you very much for Professor Nongla for your presentation. Very nice presentation.
So now I cannot hear anyone. So.
Okay, thank you for your nice presentation. You present about how to scale up and based on the experiences in the material development. Okay, to all our audience, we will have a 15-minute to discussion session. So please raise your hand. Maybe some have a question to Professor Rames. Professor Rames is present about the supercapacitor and especially for the solid electrolyte. Okay, maybe Dr. Endah. And another one, we want to find three participants. The first from here, and the second maybe from this side or another side. Okay, the second from Dr. Agus. Okay, we have two participant questions. Okay, Prof. Endah, monggo.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm Endah Ratnotiartanti from the Center of Excellence Electrical Energy Storage Technology. I'm research on hybrid polymer electrolyte for lithium-ion batteries based on PVDF polymer by non-solvent induced phase separation method. I'm interested your presentation on third generation polymer electrolyte. How about the development of the third generation polymer electrolytes on lithium-ion battery application related to safety and compatibility issue with electrode. Thank you for Prof. Rames.
Dr. Enda, the question is about the safety for PVDF in the third generation. Yeah.
Yeah, third generation safety and compatibility with electrode.
Electricity process. Okay. The second question maybe for Professor Agus.
Thank you very much, Pak Anik. First of all, thank you very much, Prof. Rames and Prof. Nongla, for your willingness to share in this conference. We hopefully we can strengthen our collaboration in the future by, this is the only one event, but we hopefully we can create another event and another research collaboration in the near future. We are also interesting actually in the super cap theory, Prof. Rames. We also have researched in this device around maybe 2-3 years up to now, and I realized that this capability in the term of current density and also in the life cycle it's better compared to lithium ion, but the problem is still in the capacity. Of course it's below lithium ion, but maybe better than supercapacitor. To be implement in the real application is still challenge how to improve the capacity of the supercapacity. Do you have any idea or maybe some another approach to improve this capacity? For Prof. Nongla, it is interesting that know that your institution, your university also have many research on the battery from the lab to scale up. I just want to know, maybe you have some experience on the commercialization of the battery, because in here we still have problem in reducing the price of battery. How the strategy in Thailand? Thank you very much.
Thank you very much for Professor Agus and Dr. Enda. There are 3 questions. The second, the 2 questions from 2 Professor Rames and 1 question for Professor Nongla. So time is yours to answer the question.
Okay, thank you for the the queries. Okay, the first one regarding the third generation polymer electrolytes. So first of all, the third generation polymer electrolytes was very much needed. The second generation having the problem with the mechanical properties. So when we talk about the mechanical properties, the stability is also an issue, and then because of that the safety become an issue as well. Because like initially the reason we are changing, because your questions about the safety and compatibility, right? So the first of all, why these generations of polymer electrolytes comes first of all, the solid electrolytes, because of the safety issues with the liquid electrolytes. So when wanted to improve this, its safety need to be much better compared to the liquid electrolytes. But when we use a second generation which are plasticizers, the problem again will be the handling issues. So that's not very good as well. But what happened here is the third generation is where we actually using the nanoparticles. So the nanoparticles, the suitable nanoparticles, for example, they must be below 100 nanometer by what you call by definition. But to make the compatibility very well, it is advisable to have the nanoparticle size below 20 nanometer. So one of the things that actually what we did is we got a supply from a company from Germany, where they supply with us silica SiO2 nanoparticles, which are around 7 nanometer. So these 7 nanometer, it is actually like if you just in a spatula or something like that, you can even see the nanoparticles like a flying, So like a dust, like a flying. So when we really, it's nanoparticles, because nanoparticle the range is like up to 100, correct or not? So that means if you can reduce to 20 nanometer and below, the compatibility become very highly possible. So we can get a high compatibility. So we can do some like complexation studies to actually improve the compatibility. So another thing is regarding, that's about the compatibility. Regarding the safety, when you make the second processes, which are very highly flexible, difficult to handle, by adding these nanoparticles, even like in a small amount, it's going to be like a huge amount, just you need like a below 10 weight percent only. So when you use a below 10 weight percent, the whole structure from such a flexible, they become like a more like a solid. So that means the safety issues when you use it in the device, they become like a full solid state compared to the earlier one. Because with the plus sizes, because they are highly flexible, when you compress, some part of the electrolyte still can come out. So that can be a difficulties in packaging. But by using these things, both the safety and the compatibility can be compromised. Okay. Thank you. Okay. Second thing is regarding the supercapacitor. The current density and life cycle, of course, is really improved. Like what Prof. Agus said, is like the capacity is always an issue, because in the real case, for us to get the high capacity is very difficult. Because some of the properties, when you do this supercapacitor, they shows better than batteries. Some shows better than supercapacitors. But to get the ultimate values to show both also better than supercapacitors and batteries is always a difficult task. So that's where the research is going on. So one of the ideas that we currently are doing and really what I call like going towards a good direction is by using hydrogel polymer electrolytes. So this hydrogel actually can give a good what I call like capacitance. So now recently we got a new projects where we are using the hydrogel polymer electrolytes to replace the current liquid and the solid electrolytes. And the other one is a Mexine. I'm sure you heard about the Mexine. So this Mexine actually is they said is like a two-dimensional materials which is expected to replace the graphene. So this Mexine actually shows a good property as well, but I still don't have the data to see how this, what I call like a combination of this hydrogel electrolyte and Mexine can shows a good capacity. So this one I think we still need to work more towards to get both the values are comparable so that it can shows better than supercapacitors and batteries. Thank you.
So the answer is for the Dr. Indah, you need to use nanoparticle around less than 20 nanometer, and for the Professor Agus, you need to try maybe like use hydrogen polymer or other this magazine. And okay, for the third question is for Professor Nongla, is about how to commercialize the issue for commercialization in Thailand. Okay.
Okay. I think the question that Professor Akut has is legitimate, right? But it's not easy to answer. It's not easy to commercialize raw materials to products with cost competitive with very players. Right, but we have to have a cutting-edge technology that really answers the questions to the pain point of all manufacturers. Then commercialization of new technology will be possible. That not depends on cost only. Yeah, I think just improvement of safety is one of the things, right? So that's why we're moving toward newer and newer technology. To be honest, for us, we make batteries and we sell battery products, but the price of our products is still higher than the imported from, of course, from China. But since it has some angles of applications and angles of properties that our customer wants or need. For example, our product always embedded with IoT system that track the safety of batteries. So even though our core innovation is on materials, but eventually in order to commercialize, it still need end products from users' requirements. So I don't know if that answer your question directly, but I just want to emphasize and also motivate and encourage anyone to do new innovation in order to try to get them into a practical application together, be part of the ecosystem together. Yeah.
Okay, so still have a challenge to improve the cost.
Very
And
challenging.
another one, how about the regulation or national standard in Thailand? Are you develop something like about national standard or regulation, maybe something like that?
Yes, we do have national standard, right? And lithium-ion battery product itself is a required certificate product. So that means if you don't have this certificate, you cannot produce and cannot bring it out to the market. So that's why, as I mentioned, that's why the facility is standard-oriented. Standard in this case, also in terms of harmonization of parts as well. We talk a lot on swapping batteries for motorcycles. This one is a big issue in our ASEAN communities, especially Thailand, Indonesia, and Malaysia, because we are the end user of motorcycle, right? But we don't have any common parts that we can share or use together. Right. So this one is still going on, so we involve on that. In terms of testing facilities as well, we do have national level testing facilities from small batteries to EV, but I think this is not yet enough for especially small company because those are very expensive to do, right? So if we do have smaller and smaller testing facilities, it will help smaller companies like us to reduce the cost of bringing our products into real market.
Okay, thank you for Professor Nongla. We have a similar problem, I think, in Indonesia and in Thailand. Okay, about the standard. Okay, maybe we have another for the audience. They have another question. Okay, Dr. Arif. So.
Thank you for the opportunity. I am Arif Jumari from Center of Excellence for Electrical Energy Storage Technology. My background of research is about ion battery recycling. I am interested about the replacement of lithium by ion of sodium on the recycling of battery. Can you explain deeper about the method and about the result of replacement of lithium by sodium? Thank you. The question is to Prof. Nonglak.
Okay. All right.
Okay.
So as I mentioned, this is a new concept, right? So replacing one ion to another ions and using in energy storage application is a concept ideas for potential future batteries, right? If we can change any ions, especially the core ions that transport inside the battery, we can change type of battery anyway. So the method that we attempt to do at the moment are two methods. The first one is using electrochemistry. This one is very hard to scale. So basically you need a system that you discharge your lithium ions from the system first, disassembly, and then assembly and charge the sodium ion into the structure. So it's a long process step. The more practical one is using chemical method. But ion exchange using chemical method is widely used in glass industry, but not yet in ceramic materials, just like in battery system. So because ion exchange in our case mean the level of exchanging is on the ion level, the scale is very, very small. Not like in the glass industry that they only do surface exchange of the ions. So this one, the electrochemical exchanging, we can do probably more than 70% yields, but for the chemical ion exchange, it's still very difficult, to be honest. Yeah.
Thank you for Prof. Nongla. You have a very good idea, I think, for us. We have a new idea how to come out the lithium from the system, but this time is still in the concept, and other is for the laboratory, I think. Okay, because we have didn't have a lot of time, so thank you for. Please give applause to Professor Nongla and Professor Ramesh. It's very nice presentation, very good discussion, and we have got many ideas how to maybe to solve this problem. We can make collaboration between Indonesia, Malaysia, and also Thailand, how to scale up the battery, and also how to find out a new material and new idea. Okay, thank you very much for all of the participants and the audience. Thank you.
Thank you for the insightful speech, and thank you to all attendees who participated in the discussion. It was an amazing discussion where we could expand our knowledge. And for the next agenda, we would like to invite Professor Dr. Ramesh Subramaniam to capture this memorable moment together. And also we invite Professor Agus Purwanto to give a souvenir and certificate for the speakers, and Dr. Mujtahid Kalvesinia to give a souvenir and certificate for the moderator. To Professor Agus Purwanto and Dr. Mujtahid, you may please come forward.
storage technology, testing services, training, industry consultative, incubation and commercialization to improve competence. This institution has produced featured products. Molina Electric Car. Public street lighting. Active material. To create the best product, CEFEEST continues to develop next generation battery, active material from local raw materials, technology startup battery-based, ICESTA International Journal. CEFEEST has carried out activities and collaborated with various parties including workshop on battery and energy storage technology, kick-off battery production, lithium-ion battery soft launching, rector visit from Bandung Institute of Technology or ITB, rector visit from 10 November Institute of Technology or ITS. Toyota Astra and the Ministry of Industry visit. MOU agreement with PT Pertamina. Teaching factory launched by the Ministry of Research, Technology and Higher Education of the Republic of Indonesia, Mohammed Nasir. Here is the University Center of Excellence team for Electrical Energy Storage Technology. CEFEEST continues to support development technology by utilizing local. University Center of Excellence for Electrical Energy Storage Technology or CEFEEST. Recognized as BUIPT UNS Electrical Energy Storage Technology is one of the programs from the Ministry of Research, Technology and Higher Education to strengthen innovation institutions in the university environment. Managed by Universitas Sebelas Maret, CEFEEST uses on lithium battery development. In 2012, this institution initiated the Molina program, which developed into lithium batteries at Universitas Sebelas Maret. CEFEEST has the vision to be the center of energy storage technology development for electric vehicle applications and the leading renewable energy in Indonesia by 2025. The facilities and infrastructure provided are battery laboratory, lithium battery mini plant, active material mini plant, test equipment and characterization. Charging station. Administration and training building. conducts research and development of energy storage technology, testing services, training, industry consultative, incubation and commercialization to improve competence. This institution has produced featured products which are battery pack, two-wheel and three-cycle electric bike, Molina electric car, public street lighting, active material, To create the best product, CEFEEST continues to develop next generation battery, active material from local raw materials, technology startup battery-based, ICESTA International Journal. CEFEEST has carried out activities and collaborated with various parties including workshop on battery and energy storage technology, kick-off battery production, lithium-ion battery soft launching, rector visit from Bandung Institute of Technology or ITB, rector visit from 10 November Institute of Technology or ITS. Toyota Astra and the Ministry of Industry visit. MOU agreement with PT Pertamina. Teaching factory launched by the Ministry of Research Technology and Higher Education of the Republic of Indonesia, Mohammed Nasir. Here is the University Center of Excellence team for Electrical Energy Storage Technology. CEFEEST continues to support development technology by utilizing local resources as Indonesia's future innovation energy. University Center of Excellence for Electrical Energy Storage Technology or CEFEEST, recognized as BUIPT UNS Electrical Energy Storage Technology, is one of the programs from the Ministry of Research Technology and Higher Education to strengthen innovation institutions in the university environment. Managed by Universitas Sebelas Maret, CEFEEST uses on lithium battery development. In 2012, this institution initiated the Molina program, which developed into lithium batteries at Universitas Sebelas Maret. CEFEEST has the vision to be the center of energy storage technology development for electric vehicle applications and the leading renewable energy in Indonesia by 2025. The facilities and infrastructure provided are battery laboratory, lithium battery mini plant, active material mini plant, test equipment and characterization, Charging station. Administration and training building.
Ladies and gentlemen, the second keynote session will be start in 5 minutes. Please kindly be seated.
CEFEEST conducts research and development of energy storage technology, testing services, training, industry consultative, incubation and commercialization to improve competence. This institution has produced featured products which are battery pack, two-wheel and three-cycle electric bike, Molina electric car, public street lighting, active material, To create the best product, CEFEEST continues to develop next generation battery, active material from local raw materials, technology startup battery-based, ICESTA International Journal. CEFEEST carried out activities and collaborated with various parties including workshop on battery and energy storage technology, kick-off battery production, lithium-ion battery soft launching, rector visit from Bandung Institute of Technology or ITB, rector visit from 10 November Institute of Technology or ITS, Toyota Astra and the Ministry of Industry visit, MOU agreement with PT Pertamina, teaching factory launched by the Minister of Research Technology and Higher Education of the Republic Indonesia, Mohammed Nasir. Here is the University Center of Excellence team for electrical energy storage technology. CEFEEST continues to support development technology by utilizing local resources as Indonesia's future innovation energy. University Center of Excellence for Electrical Energy Storage Technology or CEFEEST, recognized as BUIPT UNS Electrical Energy Storage Technology, is one of the programs from the Ministry of Research Technology and Higher Education to strengthen innovation institution in the university environment. Managed by Universitas Sebelas Maret, CEFEEST focuses on lithium battery development. In 2012, this institution initiated the Molina program, which developed into lithium batteries at Universitas Sebelas Maret.
Ladies and gentlemen, we welcome you again to continue this conference. We expect that all of the attendees have already taken a break and ready to move to the next agenda. Now, we move to the second keynote speech, which will be moderated by Mrs. Inayati, PhD, and our speakers are Mr. Rahayu Ginanjar Siwi, ST, MSc, and Dr. Sunu Herwi Pranolo, ST MSc. We would like to invite our moderator and speakers to come forward. Ladies and gentlemen, please kindly give applause for our moderator and speakers. Ladies and gentlemen, to make sure the session runs smoothly, I'd like to introduce you all to our dear moderator, Mrs. Inayati, PhD. She obtained her doctor degree from University Teknologi Malaysia and her master degree from Universitas Gadjah Mada. She has certified in International Internal Quality Auditor 2023 and certified in International Training of Trainer 2024. To Mrs. Inayati, PhD, the floor is yours.
Thank you, Aditya. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon for everybody. Thank you very much. I'm here appointed as the moderator for two keynote sessions, two keynote speakers. Yeah. First one is Mr. Rahayu Ginanjar Siwi, MSc. Yeah, from PT Pupuk Kujang, Indonesia, and Dr. Sunu Herwi Pranolo from Universitas Sebelas Maret. Before we start sharing the information, sharing experience from both of the speakers, I would like to read the curriculum vitae from Mr. Rahayu Ginanjar Siwi. Yeah. Mr. Rahayu Ginanjar Siwi graduated from Chemical Engineering Institut Teknologi Bandung in 2012 and then continued his master program in the University of Manchester, focused on advanced process integration and design. And then he was awarded as a professional engineer from Program Profesi Insinyur from Institut Teknologi Bandung. Mr. Ginanjar is very passionate focusing on energy conservation since first time joining Pupuk Kujang, yeah, in process engineering division. He was experienced also on conducting energy audit and on evaluating the efficiency of significant energy user. So this is the brief curriculum vitae from Mr. Ginanjar. And the second one is the curriculum vitae from Dr. Sunu Herwi Pranolo. He is a lecturer, senior lecturer in Chemical Engineering Study Program, Universitas Sebelas Maret, with the education bachelor degree in Chemical Engineering Universitas Gadjah Mada, and continued his master degree at Otto von Guericke Universitas Magdeburg, yeah, in 2000. And then he was awarded with a doctoral from Institut Teknologi Bandung in 2009. His research interest experiences, he is focused on biomass conversion technology into heat and electricity, mainly using thermochemical technology, such as combustion, gasification, and pyrolysis. Besides technology, environmental impacts on the application are also considered through life cycle assessment, LCA. Several industrial sectors have cooperation not only in technology, but also environmental aspect. For example, PT Bada NGL, PT Tirta Investama, PT SKS Listrik, etc. That's all the brief curriculum vitae for our two speakers. And the first session is given to Mr. Rahayu Ginanjar Siwi. We will give you 30 minutes to share your experience to us. Thank you very much. The floor is yours.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for Mrs. Inayati for the introduction. Good morning, ladies and gentlemen. There is the Honorable Dean of Technical Faculty in UNS, Professor Dr. Wahyudi Sutopo, the respected Head of Prodam Suci, Mr. Dr. Joko Waluyo, and also the Honorable Director of Pusat Unggulan Iptek, Profesor Dr. Agus Purwanto, and also the respected guest speaker from Malaysia and also from Thailand. It is a great honor for me to speak in front of you here today, in front of the lecturer, researcher, and also some student. It is a very great experience for me too. Thank you very much for the chance for me. And also, I would like to greet Mr. Suno as well. So I just know that Mr. Suno is actually from ITB too, ya Pak ya. So in 2009, so I think we have met before Pak, informally maybe ya Pak ya. So before I begin the talk today, I would like to convey the best regard of my President Director of PT Pupuk Kujang, Mr. Mariono. He is a very enthusiastic, very active, very good leadership person as our President Director. He is also very education enthusiast actually. Usually he always want to attend this kind of event by himself, but unfortunately this week it is a very busy week in Pupuk Kujang because we are hosting the centralized meeting of the Director of PT Pupuk Indonesia Holding Company. So it is quite busy week in Pupuk Kujang, so he is very sorry he cannot come to this agenda today. And then I would like to introduce myself first. So my name is actually kinda unique. It is always mess the number of the student when I was in school, especially in junior and also in senior high school. There is always a mistake in the number of the student of a female and male student, because you know my name is quite unique. From the left and right you can see my name is quite girly, and in the middle is actually my call name is Ginanjar. So please you can call me as Ginanjar today. So in this special occasion I would like to share Pupuk Kujang experience regarding the effort of my company to increase the business growth and also the sustainability. Yes, before going to the action that we have done in Pupuk Kujang, I would like to introduce my company too. So actually Pupuk Kujang is the member of the Pupuk Indonesia Holding Company. It is the holding of Indonesian fertilizer manufacturer. It is a big company. It is the ranking is actually the the number 5 of the urea fertilizer production in the world. So it is quite a big company. And Pupuk Kujang is the member of it. So it has 10 subsidiary company. 5 of them are the manufacturer of fertilizer, and the 5 remaining are just the supporting. So like they are doing the supplying the utility, supplying the chemical, supplying the design, and also the engineering project, etc. It was actually Pupuk Sriwijaya established in 1959, but since 1997 it is appointed by the government as a holding for pupuk or for fertilizer company in Indonesia. So Pupuk Kujang is one of them. And then this is the overview of my plant in Pupuk Kujang. It is situated in the Cikampek. If you know Cikampek or maybe not. Actually, I just know Pupuk Kujang when I just graduated from ITB. Before graduating, I never know about the Pupuk Kujang. I know it, but I never know that it is in Cikampek. Actually, very close to Bandung. Maybe if you are using the highway, no more than 1 hour from Bandung, and also 1 hour, one hour and a half to Jakarta. So it is the middle of Bandung and Jakarta, actually, quite near to the big city. But Cikampek is like a small city, so it is it makes sense if you to know Cikampek. But yes, our area coverage actually quite large, quite wide. This is like 510 hectares, but most of it are most of it are the plant area, but most of it actually is industrial area. We call it kawasan industri Kujang Cikampek, Kujang Industrial State. In Pupuk Kujang we have 2 trains of urea plant and also 2 trains of NPK plant. So you know urea is actually a single fertilizer that supply only nitrogen, whereas the NPK are actually compound fertilizer. So it supplies 3 main nutrient of the plant, which is nitrogen, phosphorus, and also the potassium. Another product of Pupuk Kujang is also ammonia liquid. Ammonia liquid with the concentration is around minimum 99.5%. And then we also supply organic fertilizer. We also has CO gas, carbon monoxide, CO2 liquid, and the special characteristic of our product, CO2 product, is actually it is food grade. So if you are familiar with the carbonated drinks, I think it maybe comes from CO2 from Pupuk Kujang. And also we also just recently we also built a dry ash plant in Pupuk Kujang that is convert the liquid into a solid phase of the CO2. So we have 2 trains of urea plant. We call it Kujang 1A, and it was built on 1975. And then the second one we call it Kujang 1B. It was built on 2004. And we have also 2 NPK plant. The first one was built on 2009 and the second built on 2015. This is the profile of our plant. Please, you can notice that Kujang 1A and Kujang 1B are actually having the same capacity. Kujang 1A is for ammonia product. We can produce 1,000 metric ton per day, and for the urea is 1,725 metric ton per day. And for a year it is around 330,000 per year, and for urea is 570,000 per year. So it is quite big. You can imagine that 1 metric ton is like you have maybe a vessel of 1 cubic feet, like 1 meter, 1 meter, 1 meter. So you multiply it with 1,000, and that is our capacity for a day. So it is quite big. Kujang 1B has the same capacity, but you can notice that the gas consumption as our main feedstock is a lot less than 1A. So 1A using 60,000 BBTUD and 1B is 42,000 BBTUD. That is for the urea plant. Actually, compared to another member subsidiary company of Pupuk Indonesia, Pupuk Kujang is in number 4 of the capacity. So we have 5 fertilizer manufacturer subsidiary of Pupuk Indonesia, but Kujang is number 4 because in West Java the supply of natural gas is decreasing from year to year. So we are right now are trying to get more new source of natural gas, and hopefully we can increase the capacity in next 2 or 3 years. That is the urea plant, and for the NPK plant, it is quite. We have two similar plant with the same capacity, with the same technology as well. And the capacity is 100,000 metric ton per year. We also, this is for the granule NPK, and we are, so the characteristic of the granule is you can see the product is like round and circle, and the bottom plant is NPK blending. It is like, you kind of like making a cake, so really just mixing it together without any need to form the product as a round, so just like very like a cake. This is the NPK blending, and the capacity is quite big. It is the combination of two granule NPK plant. This is the closer look. So every time you see a very tall concrete structure from very far, it is usually the landmark of fertilizer plant. So we call it this structure Priling Tower, Menara Pembutiran. So it is Priling Tower. The right side is Kujang 1A. This is the oldest plant, the old plant, sorry. This is the second oldest in Indonesia actually, and still operating until now. And the left side is Kujang 1B. So we have only two, but the technology is quite different from each other. So it is lucky for me because I am a process engineer. My background is actually chemical engineer. So it is I'm very lucky to manage two plants that is very different age. So the oldest and quite new, and the plant that is built after 2004, actually the technology is quite similar with the Kujang 1B. So I'm very lucky, even though just two, but I get the whole knowledge of plant in Pupuk Kujang. So it's quite interesting plant to see. If you have, maybe someday I have some chance to visit, I would like to welcome you in Cikampek. This is the aerial view of Kujang plant. You can imagine like you are now standing up in the top of Priling Tower 1B. So we are standing in the top of Priling Tower 1B. This is the area of our plant. Maaf, backnya gini, yeah. Okay, a lot of things to see, but as a comparison, you can see in the corner left, there are some cars there parked on there. As a comparison, that this is very big actually, yeah. The car is quite small in this picture, okay. So this is the overview of our process. Quite simple diagram, but actually if you deep down into the detail, you can see a lot of complex process in it, but I will try to explain to you in quite simple way. So urea plant actually has minimum three blocks of plant. So the first one is, we call it utility plant. The second one is ammonia plant, and the third is urea plant. It always comes like this. If you have urea plant, you has to build ammonia and utility plant. But if you only want the ammonia, you don't need to build the urea. That's the characteristic. So our feedstock is only three actually. Our main feedstock is only three. The first one is, the cheapest one is actually the air. The same air that we breathe every day. Air. No additive, no other substance to be added, just air. And the second one is water, and we got it from the river. And the third one, and it is the most expensive one, is actually the natural gas. That one was, I already told you before that the supply is decreasing every year. So the water and natural gas will be received by the utility plant. The gas will be like filtered, screened to remove the debris, the particulate, the unwanted hydrocarbon, etc. And then the river water will be processed into many things. The first one, of course, the clean water, or we call it a filter water here, cooling water, and also demineralized water. So we also have like a PDAM inside our plant too. So if you are chemical engineer and you are working for fertilizer plant, you will not have any lesson to be left. You will use all of the knowledge from your campus, from your university, and applied it in the plant. It's quite interesting plan for me as a chemical engineer actually. So we also have like a demin plant and also PDAM, etc. And we use the natural gas as a fuel to generate some steam. So it not only just to be screened but also used as the fuel, and then the gas will be flows into the ammonia plant with the demin water. It will be react with the air and become two product, which is liquid ammonia and CO2 gas. And we use that source this material to convert into urea fertilizer. This is the urea fertilizer. I hope all of you have ever seen it before in real, because it's actually quite fascinating when you imagine like it comes from water, air, and gas, completely different things, but become solid. Like it's quite interesting for me. I always enjoy talking about the process in my plant. So this is the characteristics of the plant. It involves all type of chemical engineering operation, consume highest energy as natural gas and electricity compared to another petrochemical industry. And it is operating in non-stop, 24 hours a day, 7 days a week. And we expect it to be operating in 365 days per year. We do the scheduled maintenance every 2 years. We call it turnaround. That is the busiest time, the busiest period in our plant, because a lot of people coming. We have to replace some catalyst, etc. We have to do major maintenance, our equipment, anything. It is quite interesting thing to see every year. And this is the process of NPK. It's actually very simple. It's like literally just like making a cake. So I think the crucial one is the feeding system. As long as you adjust the flow rate of the feeding, you can get any formula of NPK that you want. So in Indonesia right now, the subsidy formula for NPK is 15, 10, 12. 19 plus 12, sorry. 15, 10, 12. The ratio of NP and K, 15, 10, 12. But we can also adjust it as anything as we want. We also has another formula that is compatible with another specific plant. I will tell you later. So it's like mixing it together, going into the granulator, and it will become round, and then we inject some steam there so that the raw material will be mixed, sticking together. And then because we inject some steam, so it will be wet, so we have to dry it using a dryer. And then because the dry is hot, so we have to cool it using a cooler. And then we screen it. The on-size will be goes into the coater, and into the finally goes to the baking machine as a final product. Yes, so when I received the invitation, it actually talking about the SDGs. So like unintentionally, Pupuk Kujang is just like maybe 2 weeks ago, our director is talking about this as well. So lucky for me, so I just have to repeat what he said before. So you can search about SDGs in your cell phone. It's quite easy. So it's actually like 17 Nobel goal that is states by all of the member of United Nations in 2015, and it was expected to be achieved on 2030. So it's like 6 years in the future. And based on what I understand right now, actually there are a lot of things that is inhibiting the goal, but especially the COVID and also war between countries. Yes, but we still expect to reach this goal on 2030. there are 17, and you can read it by yourself. So in Pupuk Kujang we divide it into three pillars. The first one is social. This is our corporate social responsibility program in my company. So from social pillar we have program Makmur or prosperity program. So many. Like we are doing the any effort that we can do to achieve this goal as well, because it was dictated by the government. As a state-owned company, we have to obey what the government said. So this is the program that we implement in order to achieve the goal. Many things. You can ask me later. So I think the first one that is very relevant with the SDGs is actually program Makmur or prosperity program. It is like CSR, that is what you call it, like coordinated program between multi-component, multi-element in the supply chain of crop, farmer. So the element is like farmer, project leader is Pupuk Kujang, financing body, like we try to help the farmer to get some investment from another company, for another institute, for another institution. The agro input is also managed by Pupuk Kujang, so we try to give any information that is beneficial for the farmer. For example, the lab analysis of the soil, and also the new technology that maybe can be applied by the farmer as well. And the agricultural technology is also it is actually done by Pupuk Indonesia. So this program is initiated by Pupuk Kujang and then adopted by Pupuk Indonesia, and all of the subsidiary of Pupuk Indonesia has to implement this program too, this kind of program. And we also have some coordination with local government to make sure that we are targeting the right farmer, and then we also find some off-taker, and we give also the insurance to the farmer, so that when the yield is not what they are expected, they still get some profit from the program. So this is the benefit, increase in agricultural productivity. So I think in Garut we can increase the productivity of corn fields from 4 to 5 ton per hectare. Increase after this program is 7 until 8 ton per hectare. So that the farmer profits also increase, and then we also try to introduce new technology to the farmers, and then of course because we are selling the fertilizer, we always try to promote using the fertilizer, but of course wisely, as the needs of the soil and also the plant, not just jump it excessively. No. This is the activity of program Makmur actually. So of course it will be done by multidisciplinary knowledge science, from the agricultural, from the chemistry, from the economic, from the technical, everything. All of the program study in our university maybe can be involved in this program. Okay, and the second one is actually Kujang also try to tackle the challenge from the nature. So we are doing some research in our company. Of course, it will be done by chemistry graduate, and also from the agriculture graduates as well. So some of the product that has been published or released by Pupuk Kujang is, the first one is like CRF, control release fertilizer, not just low but control. So we involve some microbiology, some microorganism, and I mean in this fertilizer. So it will be released when the plant is needing, when the plant is in it. So it's quite a new product that we found in Pupuk Kujang, and we also produce. This is the most favorite product of our company Pupuk Kujang is this NPK formula. This is the rice plant specified NPK 3068. This is non-subsidy, of course, and the price will be quite expensive, but beneficial, very beneficial for our farmers. And then we also have the liquid organic fertilizer, is pupuk hayati, teman-teman. We use many things like garlic, onion, etc. And I don't know the complete composition of it, but actually it's not from chemical substance, no. Everything is from organic. And then we also having the high grade manure, pupuk kandang. So, but of course we give some fortification on it. We give some nitrogen, we give some microbial, so that it will be beneficial for the soil and also for the plant as well. This is 5 minutes. Sorry. Next is fruit plant specified NPK and also another formula of NPK. This is what we do to tackle the carbon emission issue. We use some electricity. Actually, Pupuk Kujang consume 7 until 8 megawatt per hour of electricity, and 2.5 of them are supplied from the renewable source of electricity. We have some coordination with PLN. And in this and in next year, I think next year we are having a plan to fully using all of the electricity from renewable source. We also using the hydropower off grid from the PLTA, and we also install some solar panel in our plant as well. The capacities you can see in the in the slide. And we are trying to convert all of our vehicle into electricity, starting from the easiest one, which is the motorcycle. We already have 40 of it. And then we are also, when I talk about the process of making urea, we are using ammonia and CO2. All of the ammonia will be reacted with all of the CO2 from ammonia plant. So every time we sell some ammonia liquid, we have some emission of CO2, and then because of that we can use the emission of CO2 to make another product, which is the CO2 liquid and also the dry ash. So it is like the development of our plant. And then we also try to reduce improve the quality of our effluent. So we are using some chemical to maintain the quality of cooling water. So we put we inject a lot of chemicals in the cooling water, so that when it is discharged to the environment, it has a lot of unwanted ion. So we try to minimize we try to convert. We substitute non-phosphate with the polymer that is more environmental friendly in our treatment. We are also using what we call it superior catalyst. Every time we have to put our catalyst in service, we have to use some natural gas to activate it to reduce the catalyst. But when we are using the new catalyst, we don't need some reduction process, so we will not burn some gas, because of when we need to reduce the catalyst, it consumes 24 hours of natural gas, 2 days, so 48 hours without producing anything. So it is quite a big movement as well in our plant. And this is the trends in fertilizer company right now. So from the first session, we are talking about the solid energy carrier, because it is battery. But in fertilizer, in ammonia plant, actually ammonia is considered to be the future fuel, everyone. So we can generate ammonia from water by using the renewable electricity. So usually it will be located, the plant will be located far away from the settlement, from the population, from the global area. So we generate it far away, and then we use the electricity from maybe from the wind or maybe from the sun, and we use the electricity to convert water into the hydrogen and also oxygen, and we use the hydrogen to generate ammonia, and then the ammonia we can deliver it everywhere that we want. We can use it as the fuel, we can use of our car, and we can also use it as the fuel for our boiler, etc. As I'm talking right now, Pupuk Kujang already doing some feasibility study with PLN. They are producing green hydrogen right now, and maybe in this month they will send the green hydrogen to Pupuk Kujang, and we convert it into ammonia, and then the ammonia will be used by PLN again as their co-firing in their electricity generator. But it also comes with many challenges that maybe you can find the answer for us, I mean for the industry. The first one is the renewable electricity, because it is still quite expensive, the renewable electricity. The second one is the high efficiency of electricity module. And the third one, it is the sustainable water treatment, because we will compete the water to be used as consumption and also to be used as this feedstock for the plant, for the green hydrogen. So this is the data I get from my colleague. So in the future, ammonia will be the main fuel for us. And beside all of them, we also try to implement some technology in our production facility, from the procurement, production process, logistic, and also distribution. We try to digitalize all of the process, all of our business process. I think that's all. I'm sorry for talking too much. Thank you very much for the time for me, and I would like to give the time to Mrs. Inayati. Thank you very much. Thank you.
Thank you very much, Mr. Kinajar. Can we applaud? Yeah. Very interesting, and I'm sure there are many questions, but we need to hold. We may question the speakers after the second speakers share his information. The next will be given by Mr. Sunu Herwi Pranolo. Time is yours, 13 minutes only.
Well, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. Good morning, distinguished speaker. Thank you very much, the chairwoman, for delivering me the presentation of our experiences here. Well, I would like here to talk about renewable energy for providing the heat and power, especially from biomass, which direct to the sustainable. You know, we are now focused on sustainable. Everything should be bring to the sustainable. And our focus is energy provision, which are sustainable, especially in our country, Indonesia. Well, this is the forecast growth of Southeast Asia power demand. I would like to highlight Indonesia. If we compare the Indonesia to other countries, the other Asian countries, especially Vietnam, we can see here that Indonesia energy utilization mainly now for residential, compared to our other country, our neighborhood country. Here, in this case, Vietnam. Vietnam in 2022, the energy resources were utilized more for industrial rather than for residential. While Indonesia at that time, we consumed more energy for household or residential. While in 2031, the growth of energy consumption for industrial sectors even less than Vietnam. The Vietnam is predicted consumes energy for industrial sector about 55%, while Indonesia is only 31%. What happened with this? Well, we may say that our economic growth in the point of view of industrial sector is slower than other countries. We consume energy more for household, which may for your refrigerator, for your TV set, for your air conditioner, etc. And we have to increase this. Yeah. And Indonesia power consumption now compared to 2022, to 2022, it increased 230%. While you know that in Indonesia, fossil fuel dominates energy provision. So it emits mainly CO2. And we can see on the slides here that 652 gigaton CO2 equivalent will fulfill our environment, which is increased 156% compared to 2000. Well, as our previous speaker told that the industry now shifted the energy from fossil also to renewable one. Okay, unfortunately the resources of energy in Indonesia comes from fossil fuel, which is coal, dominates 57.5%, while the oil 32.9%, and the rest comes from natural gas, which you know they emit CO2 emission. CO2 emission from coal dominates. It's about 87%. Well, it is the totally share of power in emission 45%. More of the energy resources comes from power, which means electricity. You know, we use electricity here. We use lamps, we use air conditions, means that we emit emission CO2. Such a huge, it's just 45%. In addition to that, the vehicle as well. The vehicle in Indonesia dominates with fossil fuel. Our previous researcher speakers, they talk about electric vehicle. Well, that's very interesting. They want to reduce this domination. They want to reduce the fossil domination in profit and energy provision. All of the policy authority goes to the government. The most important thing that now, well, we as technician, engineer, provide the technology to reduce such emission. But the top of them is the government. The government should publish, should authorize a policy which cover, which cover our innovation, Now, government optimistic that 23% of renewable energy will be achieved next year. What about our readiness? If we ready for it, then the government is ready also to protect our technology and to develop and to support the technology. Well, look back to Indonesian resources. As I mentioned before, that the biomass is available fast in Indonesia, and Indonesia superior in palm oil. In Sumatra Island especially, and Kalimantan Island, we are the superior producer of biomass, especially palm oil. The availability is so high, but the collectability, that's another problem. Providing the biomass is not availability matter only, but also the collectability. Palm oil, for example, it spreads all over Sumatra Island and Kalimantan Island, while the energy needs dominates in Java Island. It should be considered how to utilize such biomass for our needs. Yeah. Besides palm oil, actually we have a lot of biomass resources such as rice husk, coconut husk, corn husk, and corn cobs, and also cacao husk. But again, the availability are spread all over the country, and the collectability should be designed well, because the collectability is costly as well. Finally, the price of energy from biomass can be higher compared to fossil fuel. And our research explored how to make this technology, this biomass utilization is cheaper and cheaper. Especially palm kernel cell. As I told you before, that palm kernel cell dominates our biomass availability in this country. We are the superior palm oil in the world. The second is Malaysia, our neighbor. And as you know, that biomass comes from these industries, consists of palm kernel shell, empty fruit bunch, and mesocarbs. They have unique energy for other purposes, especially palm kernel shell. Its energy content is about 20 megajoule per kilogram, which is the highest. Well, compared to the coconut husk is the higher compared to the palm kernel shell. Well, again, we talk about the not availability but collectability. That's the problem. Our problem, quite problem. And there are also mesocarp and empty fruit bunch available from the palm oil mill industries. We in chemical engineering, Sebelas Maret University, develop some technologies for converting the biomass to energy. Theoretically, there are several technology available, from low temperature up to highest one. The low temperature normally known as carbonization, which operates at about, well, less than 400 and 500 degrees Celsius. The other is pyrolysis, where we can have not only solid fuel but also liquid fuel as well. Rather, liquefaction, which operates at 600 up to 600 degrees Celsius, even a little bit higher. And the next is gasification. We want to produce the combustible gas, which can be converted, which can be used not only for heating but also for powering the electricity. The highest temperature is combustion. Well, everyone knows what the combustion is. It is the highest temperature up to 1,500. I believe that the combustion is the oldest technologies the people knows. It needs sufficient oxygen and generated heat for any purposes. The advantages of gasification: we will have combustible gas, which mainly are CO, carbon monoxide, and hydrogen, which can be used for many purposes, not only for combusting, for heating, and also for chemicals. Many chemicals now produced from this system. I believe that PT Pupuk Kujang needs CO and hydrogen. Well, he told us, the speaker asked, that they are now design the fertilizer from coal, which the root is gasification. Okay. And I would like to show you here our project, how we convert biomass to heat. We install what we call as gasifier A, which is equipped with upstream and downstream equipment for preparing the feedstock. The feedstock is palm kernel cell here, and the product is the gas outlet from A, or gasifier. Unfortunately, the gas from this process contains many impurities, not only combustible gas, gaseous fuel, but also some impurities. It could be solid and also in gas phase. Then we have to take them out. Then we install some cleaning system. So in the E equipment, which is burner, well, we expect that the gas now is clean. Furthermore, we can use the gas for any purposes, for burning, to taking the heat, or for converting the gas into some chemicals after adding some purification system there. We already installed this system in several areas. Here is one of the example. We already installed the gasification of palm kernel cell for providing the heat for an asphalt mixing plant. We installed this system in West Kalimantan. In West Kalimantan, around 250 kilometers from Pontianak, and we installed them for heating the aggregate. The aggregate asphalt mixing plant, the aggregates will mix with hot asphalt to produce what we call is asphalt mixing plant. Asphalt plus hot aggregate, they mix it and they make a road for making a road. I'll show you the video in the last part of my presentation later. Well, we have a dream. We have a dream for constructing a green road. Not only the heat for producing the asphalt mixing plant, the asphalt mix, but also we want to install the electricity for operating this plant using biomass as well. For example, we may use biodiesel as well. Biodiesel which can be produced from palm oil. So we can fuel it. We can fuel the vehicle, for raw material transportation, for road construction, while the electricity comes from palm kernel cell. Using gasification, we have CO and H2, which are fed into the electric generator. Then we will have power for powering this plant. And for heating, we need only gasification, then we combust it. So the whole plant will be operated using, biomass. That's our dream. But now, we just operate the lower system, the gasification of palm kernel cell for heating. This is the result of our research in such asphalt mixing plant. According to civil engineer, that our system meets the requirements of asphalt quality. Yeah. It does not reduce the quality of asphalt. Well, even almost the same quality with the asphalt which is produced using fossil fuel. Normally, they produce the asphalt for road construction using IDO, which is, that IDO is a liquid fuel. I don't think it's suitable for static machine. Yeah, it's preferred to be used in moving vehicles rather than for heating. Yeah. And the quality, according to our research, that the quality of the road, which is constructed using gasification of palm kernel cell, the quality does not reduce. Normal, it's a normal quality, according to our laboratory experiment. Not only about the quality, but we have to consider also the cost for producing that asphalt, that road. Well, using gasification of palm kernel cell, it will save about 180,000 rupiahs per ton asphalt mixing. Well, the cost of fuel, especially diesel fuel here in this country, is so high, and the system cannot use subsidized fuel. It should be normal price, which is about now 18,000 rupiahs per liter for operating this. And it needs about 15 liters every ton of asphalt mixing. While using gasification of palm kernel cell, we need only 40 to 45 kilograms per ton of product. Each kilogram of palm kernel cell costs about 1,200 or 1,200 rupiahs, and we need 40 kilogram, which equivalent to, let's say, 78 to 60,000 rupiahs per ton of asphalt mixing plant, compared to 15 liter times 18,000 rupiahs per liter. Then we may reduce significantly the cost of the fuel. But using this technology, we have to invest. We have to invest the equipment. We have to invest the gasification system. While using fossil fuel, we need only burner. We need only one burner, and everything, finish. Operator, talking about operator. Well, using fossil fuel burners for this operation, it needs only, 0.5 man-hour. or less. Using this gasification, we need more, 3 times man-hour. Everything is compensated with the price of the feedstock, which is lower, much lower than fossil fuel. The second experiences of our team is green electricity. It was green IMP, and now we would like to establish a green electricity using diesel engine. Normally, we operate this using solar fuel. Solar fuel, IDO, we may replace a part of IDO using the gas, CO and the mixture of CO and hydrogen by gasification. According to our experience in the curve there, we can see that the higher the load of electricity produced, electricity generated, the lowest the fuel we need. While we use the gasification system for substituting the fossil fuel, even we may lower more the use of fossil fuel. Unfortunately, while we substitute more diesel fuel with gasifier, I mean producer gas or the gas made from gasification, the technical problem arises. What is that? It is vibration. The more we use the gas, the higher the vibration detected. That's the technical problem our mechanical engineer friends should consider. We need higher substitution, but we have to lower the vibration, mechanical problems. Well, the higher the vibration, we need more and more maintenance. It will costly again. I would like here to show you our old project. Actually, I and my team already constructed several biomass to electricity for providing the power in several remote areas, especially in Riau province and in East Nusa Tenggara province as well, Sumba. In Riau, we utilize palm drip. In Sumba Island, we use rice husk. Unfortunately, they are not in operation anymore. Why? Because, again, we have to think about the collectability. In Riau, we use palm drip, which is quite difficult to be collected and prepared before feeding into the system, compared to palm kernel shell, which is collected in palm oil mill. It's easily to take them and feed into the system. While, the palm drip, we have to collect from the plantation. The farmers harvest, while harvesting the fresh wheat bunch from the plantation, they have to cut one palm drip. And they left the palm drip and take the fruit bunch to the oil plant. collecting the palm retrieve is quite difficult. Not difficult but costly. Not so difficult but costly. Well, finally, the electricity price will be higher than government price. So nobody like it. Then we stop this system. We don't operate it anymore. Well, same case in Sumba. We use, in Sumba Island, we use rice husk for generating electricity. But different problems. Actually, in Sumba, well, we need such a qualified operators. Qualified operators. We lack of operators which are qualified for operating this system. Thus, we have to prepare not only the feedstock but also the operator for operating it. We have to educate it. We have to educate the people. We have to create a skillful person for operating this. Unfortunately, we don't have it yet. The last in the below part of this slide, biomass to heat again project using corn crop for drying the corn in around Ciamis Regency in West Java. Normally they use kerosene for heating the corn, while now we already install it. This is the cost of the fuel matter. The kerosene change, we cannot find it now. The change used with diesel oil, and they buy out the diesel oil at the subsidized price, while using corn crops. The cost for operating the process is much higher compared with the fossil fuel operation. So, well, again, it is interrupted, unfortunately. And I would like also to show you some our research which are published in several publications. The first one, both are environmental aspect, CO2 emission intensity. According to our research, that our AMP operates in using gasification may reduce CO2 up to 60% compared with diesel, using diesel fuel combustion for producing asphalt mixing plant. Because you know that palm kernel cell is biomass, and again biomass is considered as CO2 neutral. Then the CO2 generated from biomass combustion is assumed as neutral, and it goes in a CO2 cycle in the environment. Again, here we talk about sustainability development goals. Our research support the sustainable development goals from number 7, 8, 9, 12, and 13. And the conclusion that the gasification technology are auspicious, attractive, and efficient methods. We offer auspicious, attractive, and efficient methods for transforming biomass into green power and heat. The process is economically and environmentally sustainable and sufficient to meet the sustainable development goals, net zero emission, and circular economy across Indonesia. Last but not least, I have a short video. May I turn in? The committee, could you please? About our project in Kalimantan for providing the heat.
By the end of 2024, Government of Indonesia targets to increase the road infrastructure by 2,500 to 3,000 kilometers length, which needs approximately 650 tons of hot mix asphalt for each kilometer. Aggregate for producing hot mix asphalt should be heated up to 160 degrees Celsius, which requires 350 to 380 megajoule per ton production. Traditionally, it needs 8 to 12 liters of fossil fuel per ton production of hot mix asphalt. Faculty of Engineering and Universitas Sebelas Maret researchers innovated palm kernel shells gasification technology to substitute fossil fuel for that purpose. Using this innovation, the palm kernel shell is converted into fuel gas containing 50 to 25% of carbon monoxide and 10 to 15% of hydrogen. After cleaning and cooling down the gas, its calorific value is about 5.5 and 6.0 megajoule per normal meter cubic. In line with that, this innovation might reduce carbon emission by 40% compared to diesel fuel per ton of hot mix asphalt production. In addition, about 80% of palm kernel shell gasification unit is constructed using domestic components. And also, this innovation creates job vacancies for local technicians for operation and maintenance purposes. It needs 40 to 45 kilograms of palm kernel shell per minute to produce 1 ton hot mix asphalt and generates 13 to 15 kilograms of solid residue as a char. This might be a raw material of biochar, which is feasible to be a soil conditioner on a palm plantation. The road construction using palm shells gasification cuts off the energy cost of 7,500 to 75,000 per ton of hot mix asphalt depending on the fuel's prices. Last but not least, this innovation dramatically supports the achievement of the Sustainable Development Goals, completion to the latter cycle of the Directorate General of Highways, and also the National Energy Policy in a term of renewable energy application.
It was our words. Thank you, Dr. Inayati.
Thank you very much, Dr. Sunu. And now I would like to open 3 questions. Before you give the question, please mention your name and from which institution you are from. 3 questions, please. Okay. 1, 2, 3. Okay. At the left corner. Boleh minta tolong? And to whom the question is addressed? Yeah.
My name is Lintang Nurtaya from undergraduate student of Chemical Engineering, Universitas Sebelas Maret. In here I will ask to Mr. Rahayu about there are any idea or thing that PT Pupuk Kujang has done to substitute raw material, as we know that natural gas resources are reducing year by year. Maybe that from me.
Thank you. Second question.
Okay, thank you. Good morning, everyone. My name is Firman Astaputra from Sebelas Maret University. I have a question for both speakers. The first one for Mr. Ginanjar. I saw the interesting product there, control release fertilizer. If you don't mind, could you please explain more detail about that product and what kind of technology used there? And the second question for Mr. Sunu, we know that in Java, electricity production coming from most power plant coming from fossil fuel is maybe ironic because in Java we don't have coal, we don't have natural gas, and in your presentation you explain we have a lot of biomass, but they are outside Java, like palm oil based, cocoa, and any other biomass. I want to ask about the most promises if you want to replace or substitute or shifting fossil fuel resources in Java Island. What is the type of promises biomass used in Java Island, and what is the difficult challenge of these matters? Okay, thank you.
Thank you. Last one from the back. Try.
Okay. Assalamualaikum warahmatullahi wabarakatuh. It's hard for me to give a question. I'm in Transapuba, just call me Try. I'm from the Universitas Maret. Yes. Okay. So I have a question particularly to Mr. Ginanjar. Yes. Okay. To me, yes. Okay. To me, ammonia is such an interesting product because I'm a bit in it in terms of production such ammonia. So for I don't know, about 2 years or 3 years ago, I had a news that Toyota made a special machine, technically for ammonia machine consumption. So it might be a good news for us because it is the game changer for the fossil fuel. Unfortunately, I guess it's my opinion. If we use the ammonia for the fuel for our combustion system in vehicle, for example, it might be generate others emission. We know that ammonia is nitrogen and hydrogen. If we combust it directly, it might be generate NOx or something like that. What happens if it generates dinitrogen oxide, which is 200 times more harmful compared to carbon dioxide? How we mitigate it? That's my first question. And the second question, still for Mr. Ginanjar. Are we capable to generate the green ammonia based on our current situation? Thank you.
Thank you very much. So I would like to please Mr. Ginanjar to answer 3 questions. I think the question, yeah. Okay.
Thank you, Mrs. Inayati. First of all, I didn't catch your name. Sorry. What is your name? Sorry, Dek. Cahyo ya? Atau Tirta siapa?
Lintang.
Lintang. And the second, sorry, Firman, and the third? Try. Okay. Thank you very much for the question. It is very interesting question and quite difficult for me to answer it. So let me try my best to answer your question. For the first one, I think I will combine my answer for Lintang and for Try. Regarding the last question, are we capable of making green ammonia right now? The answer is maybe still quite long way for us, for Indonesia, to make green ammonia right now. I already told you about some challenges. For example, the cost of the electricity generating from the renewable source is quite expensive right now. Still compared to the normal electricity that comes from the fossil fuel. But actually, Pupuk Ujang is the only company that has the potential to make the green ammonia. Why? Because we are located near the Jatiluhur Dam. It is located in Purwakarta. Maybe Pak Sunu knows about this, or Pak Margono. I think I'm sorry. So yeah, we are locating in near what we call it, PLTA in English. Sorry. So yeah, the Jatiluhur can generate for I think 50 megawatt per hour. Of course, it will be depends on the debit of the river, but yes, the maximum capacity is around the 50 megawatt, and the only fertilizer company that located near the renewable source of electricity is only Pupuk Kujang. So yes, of course, we already do some feasibility study to make the green hydrogen. Green ammonia is still far away, but right now we are doing some feasibility study with the Jatiluhur PJT. Perum Jasa Tirta, the one that is the handle the operation of Jatiluhur Dam. But yes, the challenge is still the price. So it's not quite economical right now. Yes, we do some feasibility study. We already contact some electrolysis vendor from Netherlands, I think, to do some study for us. It is possible for Indonesia to make to make some electrolysis module that is beneficial, that is economically feasible for us. But yes, we are on the right way, but I think it is still too long. So I think that's to answer the question from Trey for Lintang. What are another source of raw material that can substitute the natural gas? So of course the first one is the water, and also we have some challenge on it because we already we also consume the water for drinking as well. So yes, it will be if it is success, it will be some challenge too for us. So we have to think about that later. But right now we are studying about that, the electrolysis. The second is what Pak Sunu has already presented to us. This is like coal gasification. I think before pandemic, yes, we have some coordination with Japan Ministry, Energy Ministry of Japan, to build the pilot plant of gasification in the Kujang Industrial Estate. We built some plant. It's quite big. I think it's around 10 tons per hour, if I'm not mistaken. And it is designed to gasify the low-rank coal, Pak Sunu. So low-rank coal, because mostly coal in Indonesia is low-rank, but the yield is quite good. But we have some trouble with the equipment because the system using fluidized bed, Pak. So it is like corroding everywhere. The pipe that is used to fluidize the coal is frequently leaking, frequently cracked. So the yield is good, but we still have some problem in the equipment. And the second big problem is actually because Pupuk Kujang is located in the middle of the line. So we have a landlocked Pupuk Kujang. The other fertilizer manufacturer doesn't have it, like PKT, PIM, Petrokimia Gresik is located near like seashore in the shore. But for Pupuk Sriwijaya, actually they don't have any shore, but they are situated in the side of Mahakam River. And so when the moon is rise and the water level is high, they can do some transportation using ship carriage. So that is the second challenge that is facing by Pupuk Kujang. So right now the plant has been demolished, and right now we are using the facility to make demin plant. So we still have the plant, but the gasification equipment has been demolished, and right now it's still left the demin plant, just the demin plant. That is the second, and I think I will give the challenge to you because in Indonesia, in the world even, the main source of hydrogen is still from the natural gas, from the fossil fuel. So of course, when you can find some route, some way to generate hydrogen economically, that will be a breakthrough, a game changer, you can call it. Yeah, you can call it a breakthrough. It will completely change our fertilizer industry in the world. So that is why what I say to any student that comes to me when we are reading the internship in Pupuk Kujang, they are doing some industrial visit in Pupuk Kujang. I was told about this thing. So please study hard, find a way to tackle this challenge for Indonesia, not for me, not for industry, for all of us. I think that is my answer for Lintang, and then I will like to move to Firman's question. I didn't answer the second question from Trey, but let me back to you later. So for Firman, yes, but unfortunately I'm not the right person to answer this, because this is from the different department, from the research department of Pupuk Kujang. Control release, what I know is actually it comes with some coating and also some microbio. But I'm not sure what kind of microbio that is used in this fertilizer, and how this microbio detects the needs of the plant. So sometimes when the plants are getting some sunlight, it will do the metabolism and will need to absorb some nutrient from the soil. But when we are not using control release in the night, maybe the fertilizer will still give the nutrition to the soil, even though the plant is not needs the nutrition. But I can only told you about this. I didn't know the complete answer of it. I will back to you later. Maybe if I have a chance, I will ask my colleague in Pupuk Kujang. But that is the overview, I think, about the control release fertilizer. So it comes with some kind of coating and microbio. And the last question from Trey, yes. I think I didn't know the precise answer of it as well. I'm sorry. Yes, when we are burn some ammonia, we get some NOx and also water. So, but hopefully, when we are supplying the right amount of oxygen, it will not convert into some of the toxic or poisonous gas. I think it will become NO2. But I'm sorry, I didn't. I know the way to make sure that all of them are become NO2 by using the right amount of oxygen, and also you can also using some additives on the burner system that we call it. The common name is actually diesel engine fluid, but the commercial name, the more popular name is actually AdBlue, AdBlue, AdBlue. You can use it. You can Google it. It is used to make sure that all of the NOx is not poisonous for when it emits into the atmosphere. But as for the NO2, I still not can answer that. Please give me a chance to find the answer later. I think that's all from me. Thank you very much.
Thank you very much. And one question for Mr. Suno.
Thank you, Chairman. Thank you for the question. I would like to share you my experiences in providing the biomass energy for electricity and for heating. Especially for heating, I have an experience with a cement plant in Java Island. which is in Cilacap, and also maybe in Tuban as well, where Pak Sulaiman now act as manager there. According to our calculation, that biomass is possible to replace some fossil fuel, which is now they use coal. But the problem arises when we want to substitute more and more. Yeah, there is a limit number for substituting the coal. According to my previous research, that it can only substitute up to 12% of coal with rice husk. It is without modifying significantly main burner. While if we want to increase it without any modification in calciner and burner, etc., the quality of the product, where that is calcium oxide, decreases significantly. So we have to limit it up to 12%, according to our experiment and calculation. The second problem is that the availability again. The availability of the rice husk in Java is spread over the islands, and the users are not the cement industries. Many industries needs rice husk in Java. For example, for producing the bricks, they need a lot of rice husk as well for drying it. Another user is we call it as tile roof. They need also rice husk for drying the roof from clay. So competitive, the high competitiveness. Then the price will increase as well. And we cannot afford it when the price increases. That's the classic problems in Indonesia, where the higher the needs, then the higher the cost. Collecting efficiency. Talking about collecting efficiency, we already verified the potential of rice husk and other biomass for substituting the coal for electric power generation. I and my friends, my team, already did a feasibility study to verify if the biomass in Java Island can substitute the coal for powering electricity in several steam power plants along the north coast of Java and southern part of Java. Well, actually, yes, it can replace it, but again, the availability and collectability. Both are the main problem when we want to apply the biomass or renewable energy, especially biomass in Java. So I don't think that Java is suitable for using biomass at high capacity. Yeah, you may use it, but the consequences are you have to compete with other users. Then you have to provide higher costs. That's the problem. Thank you very much.
Okay, thank you very much, Mr. Sunu. I think we have run out of time. I think it's wiser to finish the session. And thank you very much for both speakers who has given us very insightful speech. And thank you very much for a very nice discussion. I hope that what we learned today give us a higher spirit as a chemical engineers. Thank you very much, and I will say Assalamualaikum warahmatullahi wabarakatuh. I give the forum to the MC.
you for having me. Thank you very much. Thank you.
Thank you for the amazing speech, and thank you to all attendees who participated in the discussion. We hope that after the discussion we've done, we can enrich our knowledge. Now, we would like to invite Mr. Rahayu Ginanjar Siwi ST MSc and Dr. Sunu Herwi Pranolo ST MSc to capture this moment together, and also we would like to invite Dr. Mujtahid Kaafisena to give a souvenir and certificate to moderator and speakers.
Once again, please give applause for our speakers and moderator. Ladies and gentlemen, we are now at the end of the keynote session. For the next agenda will be a parallel session where it will be divided by 5 rooms. But before we move to the parallel session, it is time for us to take a lunch break. For all the attendees whose religion is Muslim, this building provides musalla or a prayer room at this floor. From this moment, we would like to take leave and thank everyone for your attention and participation on this keynote session. Also, for all the attendees, we would like to inform you to come on this main room again after the parallel session at 4:15 p.m. for the award announcement and closing ceremony. Thank you.
University Center of Excellence for Electrical Energy Storage Technology, or CEFEEST. Recognized as BUIPT UNS Electrical Energy Storage Technology, is one of the programs from the Ministry of Research, Technology and Higher Education to strengthen innovation institutions in the university environment. Managed by Universitas Sebelas Maret, CEFEEST focuses on lithium battery development. In 2012, this institution initiated the Molina program, which developed into lithium batteries at Universitas Sebelas Maret. CEFEEST has the vision to be the center of energy storage technology development for electric vehicle applications and the leading renewable energy in Indonesia by 2025. The facilities and infrastructures provided are battery laboratory, lithium battery mini plant, active material mini plant, test equipment and characterization, charging station, Administration and Training Building. CEFEEST conducts research and development of energy storage technology, testing services, training, industry consultative, incubation and commercialization to improve competence. This institution has produced featured products which are battery pack, two-wheel and three-cycle electric bike, Molina electric car, public street lighting, active material, To create the best product, CEFEEST continues to develop next-generation battery, active material from local raw materials, technology startup battery-based, ICESTA International Journal.
Bapak Ibu peserta semua, makanan sudah siap. Ya,
CEFEEST has carried out activities and collaborated with various parties including workshop on battery and energy storage technology, kick-off battery production, lithium-ion battery soft launching, rector visit from Bandung Institute of Technology or ITB, rector visit from 10 November Institute of Technology or ICES, Toyota Astra and the Ministry of Industry visit, MOU agreement with PT Pertamina, teaching factory launched by the Ministry of Research Technology and Higher Education of the Republic Indonesia, Muhammad Nasir. Here is the University Center of Excellence team for Electrical Energy Storage Technology. CEFEEST continues to support development technology by utilizing local resources as Indonesia's future innovation energy. University Center of Excellence for Electrical Energy Storage Technology, or CEFEEST, recognized as PUIPT UNS Electrical Energy Storage Technology, is one of the programs from the Ministry of Research Technology and Higher Education to strengthen innovation institutions in the university environment. Managed by Universitas Sebelas Maret, CEFEEST focuses on lithium battery development. In 2012, this institution initiated the Molina program, which developed into lithium batteries at Universitas Sebelas Maret. CEFEEST has the vision to be the center of energy storage technology development for electric vehicle applications and the leading renewable energy in Indonesia by 2025. The facilities and infrastructures provided are battery laboratory, lithium battery mini plant, active material mini
Bu
plant.
Windu, Bu Windu, Bu Esa, ayo masuk foto dulu Bu.
Task equipment and characterization. Charging station. Administration and training building. CEFEEST conducts research and development of energy storage technology, testing services, training, industry consultative, incubation and commercialization to improve competence. This institution has produced featured products which are battery pack, two-wheel and three-cycle electric bike, Molina electric car, public street lighting, active material. To create the best product, CEFEEST continues to develop next-generation battery, active material from local raw materials, technology startup battery-based, ICESTA International Journal. CEFEEST carried out activities and collaborated with various parties including workshop on battery and energy storage technology, kick-off battery production, lithium-ion battery soft launching, rector visit from Bandung Institute of Technology or ITB, rector visit from 10 November Institute of Technology or ITS. Toyota Astra and the Ministry of Industry visit. MOU agreement with PT Pertamina. Teaching factory launched by the Minister of Research Technology and Higher Education of the Republic of Indonesia, Muhammad Nasir. Here is the University Center of Excellence team for electrical energy storage technology. CEFEEST continues to support development technology by utilizing local resources as Indonesia's future innovation energy.
Higher education is one of the pillars of improving the quality of Indonesian human resources to become a superior and competitive human beings.
The era of Industrial Revolution 4.0 currently requires universities to be able to produce graduates who have the intellectual ability to face unpredictable social changes.
This is us, the Department of Chemical Engineering, Universitas 11 Maret. Our vision is to become an excellent chemical engineering institution in the field of chemical industry based on living natural resources at the international level according to the noble values of national culture in 2030.
Program Studi Sarjana Teknik Kimia Universitas 11 Maret berdiri sejak tahun 1998. Saat ini telah meluluskan 680 alumni. Alumni bekerja pada berbagai level nasional maupun internasional. Beberapa lulusan juga mengabdikan diri pada berbagai instansi pemerintah. Sebagian lulusan juga sukses dalam berwirausaha. Program Studi Sarjana Teknik Kimia telah terakreditasi oleh Ban PT sejak tahun 2015. Saat ini program Studi Sarjana Teknik Kimia telah terus berkembang menuju lembaga pendidikan bertaraf internasional.
Since it was established in 1998, until now, the Chemical Engineering Study Program of Universitas 11 Maret has always been one of the foremost in providing quality human resources in the chemical industry, as well as developing researchers in the field of chemical engineering and renewable energy based on natural resources. This effort is supported by 22 lecturers with 17 doctorates qualified, both graduates from within and outside the country. The Chemical Engineering Study Program also has one professor in the field of energy storage materials. With the concept of contextual learning, students learn in a comfortable environment and are supported by various facilities to prepare them to become qualified, educated workers in the future. The curriculum is also designed to answer the challenges of the increasingly rapid and complex industrial revolution. With a variety of study programs ranging from diplomas, bachelor's, and master's degrees. Since 2015, the Chemical Engineering Undergraduate Study Program has obtained the highest accreditation from National Accreditation Board. Various achievements have been won by the institution, lecturers, as well as students at the national, regional, and international levels. One of which Chemical Engineering of Universitas 11 Maret has succeeded in developing its research project in the development of rechargeable lithium-ion batteries up to the level of mass production, which is 1,000 units per day. Alumni from Chemical Engineering Study Program have been spread in various fields of industry, such as fertilizer industry, cement industry, oil and gas industry, engineering procurement and construction, consumer goods, food industry, and various other chemical industries. In addition, there are also many alumni who run independent entrepreneurs, become academics, and researchers in various related fields. Alumni are also able to complete scholarship for postgraduate studies both from Indonesia and abroad. Chemical Engineering Universitas 11 Maret, great ability, good morality. Higher education is one of the pillars of improving the quality of Indonesian human resources to become a superior and competitive human beings. The era of Industrial Revolution 4.0 currently requires universities to be able to produce graduates who have the intellectual ability to face unpredictable social changes. This is us, the Department of Chemical Engineering, Universitas 11 Maret. Our vision is to become an excellent chemical engineering institution in the field of chemical industry based on living natural resources at the international level according to the noble values of national culture in 2030.
Program Studi Sarjana Teknik Kimia Universitas 11 Maret berdiri sejak tahun 1998. Saat ini telah meluluskan 680 alumni. Alumni bekerja pada berbagai level nasional maupun internasional. Beberapa lulusan juga mengabdikan diri pada berbagai instansi pemerintah. Sebagian lulusan juga sukses dalam berwirausaha. Program studi sarjana teknik kimia telah terakreditasi oleh Ban PT sejak tahun 2015. Saat ini program studi sarjana teknik kimia telah terus berkembang menuju lembaga pendidikan bertaraf internasional.
Since it was established in 1998, until now, the Chemical Engineering Study Program of Universitas Sebelas Maret has always been one of the foremost in providing quality human resources in the chemical industry, as well as developing research in the field of chemical engineering and renewable energy based on natural resources. This effort is supported by 22 lecturers with 17 doctorates qualified, both graduates from within and outside the country. The Chemical Engineering Study Program also has one professor in the field of energy storage materials. With the concept of contextual learning, students learn in a comfortable environment and are supported by various facilities to prepare them to become qualified, educated workers in the future. The curriculum is also designed to answer the challenges of the increasingly rapid and complex industrial revolution. With a variety of study programs ranging from diplomas, bachelor's, and master's degrees. Since 2015, the Chemical Engineering Undergraduate Study Program has obtained the highest accreditation from National Accreditation Board. Various achievements have been won by the institution, lecturers, as well as students at the national, regional, and international levels. One of which Chemical Engineering of Universitas Sebelas Maret has succeeded in developing its research project in the development of rechargeable lithium-ion batteries up to the level of mass production, which is 1,000 units per day. Alumni from Chemical Engineering Study Program have been spread in various fields of industry, such as fertilizer industry, cement industry, oil and gas industry, engineering, procurement and construction, consumer goods, food industry, and various other chemical industries. In addition, there are also many alumni who run independent entrepreneurs, become academics, and researchers in various related fields. Alumni are also able to complete scholarships for postgraduate studies both from Indonesia and abroad. Chemical Engineering Universitas Sebelas Maret, great ability, good morality. Higher education is one of the pillars of improving the quality of Indonesian human resources to become a superior and competitive human beings. The era of Industrial Revolution 4.0 currently requires university to be able to produce graduates who have the intellectual ability to face unpredictable social changes. This is us, the Department of Chemical Engineering, Universitas Sebelas Maret. Our vision is to become an excellent chemical engineering.
Science without nobility is blind. The core of Universitas Sebelas Maret logo, which is a head-like shape with a flame in its center, is described as Wiku. The term Wiku is Old Javanese, borrowed from Pali, meaning an educated noble disciple. The flame, or Prabha, in the center of Wiku's head, represents the brilliance, wisdom, and nobility of the human mind. The flame also symbolizes the light of knowledge that shines and makes a positive and eternal impact on the world and humanity. Universitas Sebelas Maret, established on March 11, 1976, is one of the leading universities in Indonesia. Its noble goal is to contribute to the development of the nation through education, research, and innovation that benefit society. Universitas Sebelas Maret has built its vision and strategic plan on becoming an internationally excellent center of development of science, technology, and arts based on the noble values of national culture, focusing on enhancing specialized subject area and on developing its capacity to meet world-class standards. Universitas Sebelas Maret has established 3 centers of excellence in science and technology. The 3 centers are Center of Excellence in Lithium-Ion Battery Technology,